Look up. The sky is dark, seemingly lifeless. But then, you notice something that wasn't there before. A bizarre, almost invisible light illuminates the previously black space. It's too late to run. You're both lucky and unlucky at the same time. You're witnessing the awakening of a giant, previously dormant black hole. Is it going to swallow both you and our world? Supermassive black holes, huge space objects millions of times heavier than our Sun, live in the middle of most galaxies. But they're really hard to see or study. Most of the time they sit quietly and don't do much for a long time. That's what was happening with a giant black hole in a faraway galaxy. This galaxy is 300 million light-years away from us, in a part of the sky called Virgo. For many years, the black hole there wasn't doing anything exciting. It was quiet and resting. But in late 2019, something strange happened. The galaxy suddenly got much brighter. It started flashing a powerful X-ray light. It was something scientists hadn't seen there before. This surprised astronomers, so they started watching it closely. After a few years of studying it, scientists have concluded that the black hole has likely woken up from its quiet state and become active. Now, the middle of the galaxy is really bright. It might mean the black hole is pulling in material and producing lots of energy. Astronomers even gave this black hole a fun nickname, Ansky. And the coolest thing about all this is that it's the first time we're watching a supermassive black hole switching to an active state in real time. Scientists at the European Southern Observatory in Germany were the first to notice something strange. They used special space telescopes, like NASA's Swift and another one called E-Rosetta, to look for X-rays coming from Ansky. At first they didn't see any. Then, in February 2024, another group of scientists noticed something new – bursts of X-ray light coming from Ansky. And these bursts weren't random. They happened almost like clockwork, at nearly regular times. This kind of flashing has a complicated name – quasi-periodic eruption, or QPE if you want to make it short. It's when a black hole suddenly flares up with a burst of energy, but only for a short time. And this is the first time anyone has seen a QPE in a black hole that was waking up after being quiet for so long. These kinds of events are also super rare. Scientists only found the first QPE in 2019, and they've only seen a few more since then. No one knows exactly why they happen, but watching Ansky might help scientists learn more about how black holes behave and grow. One important tool they used was the XMM Newton Space Telescope. It's the only one that can see the very faint background light between the flashes. By measuring how dim Ansky gets between bursts, scientists could figure out how much energy the black hole sends out during each flare. You might know that black holes have super strong gravity that pulls in anything that gets too close, even stars. If a star gets caught, it can be stretched and torn apart. The pieces of the star form a super-hot glowing ring that spins around the black hole. This ring is called an accretion disk. Scientists think that the quick flashes of X-rays, QPEs, might happen when something, like a star or even another small black hole, interacts with this spinning disk. QPEs have sometimes been linked to stars being destroyed. But with Ansky, there's no sign that it destroyed the star. So scientists started thinking of other reasons. Maybe the disk around Ansky is made from gas that the black hole grabbed from nearby space, not from a torn-up star. And maybe something small, like a planet or a star, is passing through this disk over and over again, shaking it up and making it flare with bright X-ray light each time. What makes Ansky really special is how big and powerful its bursts are. According to a student at MIT who worked on the study, Ansky's X-ray bursts last 10 times longer and are 10 times brighter than normal QPEs. Each burst gives off 100 times more energy than other ones scientists have seen. And the timing is strange too. Ansky has a pattern of flashing about every 4.5 days. It's the longest wait time between flashes ever seen. These strange features are making scientists rethink how QPEs happen and what causes them. Sadly, we don't have enough data yet to know for sure. Astronomers need to watch more of these events to figure it out. Now, you might be wondering how scientists even find black holes. After all, they capture everything, even light. Indeed, these space monsters are really hard to see, they're basically invisible. But scientists pay attention to what's happening around them. It can be glowing gas and dust somewhere in space. The thing is, black holes often have a spinning ring of gas and dust around them, called an accretion disk. This ring gets super hot and shines in X-rays and other kinds of light, which telescopes can spot. It can also be moving stars. Big black holes, like the one in the middle of our Milky Way galaxy, have such strong gravity that they make stars orbit around them. Scientists watch these stars move in special patterns and prove that there's a giant black hole hiding there. This discovery won a Nobel Prize in 2020. They're also on the lookout for ripples in space, because when giant objects like black holes move or crash into each other, they send out gravitational waves. Scientists have built special tools to feel these ripples and learn more about black holes. And finally, it's bending light. Black holes have so much gravity they can bend light from stars behind them, like a cosmic magnifying glass. This trick, called gravitational lensing, can help scientists find black holes that are hiding all by themselves. Now, you should keep in mind that, unlike some stereotypes, black holes are not wormholes, magic tunnels that take you to other places in space or different universes. Once you get into one, there's no way out or to the other side. Neither are black holes some kind of space vacuum cleaners. They don't go around swallowing everything they come close to. If you're far away, their gravity is just like that of any other object with the same mass. The black hole that's closest to us on Earth is called Gaia BH1. It's about 1,500 light-years away. As for the farthest black hole we know about, it's located in the middle of a faraway galaxy 13 billion light-years away. The largest black hole we've seen is called TON 618. It's 66 billion times heavier than the Sun. And the smallest black hole is just 3.8 times heavier than the Sun and sits next to a star. By the way, all black holes spin or turn really fast. The fastest one spins over 1,000 times every second. Plus, big black holes in the middle of galaxies can shoot out particles at super high speeds, almost as fast as light. If something falls into a black hole, spaghettification occurs. This object gets stretched out in space like a noodle because of the black hole's immensely strong gravity. And speaking of gravity, if our Sun were replaced with a black hole that had the same mass, Earth and the other planets would still orbit it in the same way. The gravity wouldn't change just because it's a black hole. Scientists have discovered two main kinds of black holes. The first are called stellar mass black holes, and they're usually about 5 to maybe 50 times heavier than our Sun. The second type is supermassive black holes, which are incredibly huge. Some of them 100,000 times to even billions of times heavier than the Sun. There might also be middle-sized black holes, kind of like the in-between type, but no one has found one for sure yet. Stellar mass black holes can form when two neutron stars smash into each other. Also, two smaller black holes can join together and make a bigger one. That's one way black holes grow. But supermassive black holes are still a big mystery. Scientists aren't exactly sure how the universe creates black holes that large. Well, space just hit us with its hugest black hole collision ever. What? You didn't feel that? Well, actually, you weren't supposed to. Two absolutely massive black holes spiraled into each other and smashed together, forming a brand new black hole about 225 times the mass of our Sun. This space catastrophe must have been epic, and if Earth had been in the way, it would have obliterated in a fraction of a second. Whew. Now, this whole event happened on the outer edges of our Milky Way galaxy, and we only caught it because of a team of super-sensitive space detectors called LIGO, Virgo, and CAGRA. Now, these aren't new pop stars, and not even telescopes. They're more like giant cosmic microphones. They listen for gravitational waves, ripples in space-time that spread out when huge objects crash into each other. It feels like space is shuddering from the impact. Now, Einstein predicted such things way back in the day, and in 2015, scientists finally proved he was right. That win even scored them a Nobel Prize. So, the two black holes that collided were around 100 to 140 times the mass of our Sun. That might not sound like a big deal until you realize one thing: they're not supposed to exist. There's this weird range called the mass gap, roughly between 60 and 130 solar masses, where theory says black holes can't really form. Because when massive stars go out, they usually explode into supernovas that blow away most of their mass before anything can collapse into a black hole. So, black holes in this range shouldn't be here, and yet, here they are. This is actually the second time we've seen black holes lurking in this mass gap. The first time we detected such an event in 2019, two truly huge black holes slammed together and formed one 142 times the mass of the Sun. That's a big boy. It happened 7 billion years ago. To put it in perspective, Earth is around 4.5 billion years old. Anyway, two black holes slammed into each other in deep space. One was about 85 times the mass of our Sun, the other 66 times. And when they crashed, they merged into a brand new cosmic monster, a 142 solar mass black hole. At the time, it was the biggest black hole collision ever caught. Now, curiously, physicists weren't even sure black holes this massive could even exist. Scientists had this idea that stars that big would just explode and fizzle out, not become black holes. So this collision basically walked in, broke the rules, and left everyone rethinking the textbook. Now, fast forward several billion years. Hey, it's Brightside, we can do stuff like that. After traveling across space for longer than the Sun has ever been around, the ripple from that crash finally reached Earth. On May 21, 2019, it hit the LIGO detectors in the US and Virgo in Italy, shaking their laser setups for about a tenth of a second. One little cosmic bump, and suddenly scientists had proof those giant black holes were real. As for that missing 9 suns worth of mass, it turned into pure energy in the crash. That's what powered the gravitational wave strong enough to hit us after 7 billion years on the road. By analyzing the wave's shape, basically its wiggles, researchers could figure out exactly what kind of black holes were involved and how massive they were. We could compare it with hearing the faintest echo of a giant cosmic drum solo and being able to tell what kind of drumsticks were used. Now, in any case, every time something like this happens, it pushes scientists to rethink the rules of how black holes are born. The leading theory now is that such giants don't come from dying stars at all. They probably form when other, smaller black holes merge again and again, like cosmic Lego bricks, snapping together over time. Normally, black holes fall into two camps. There are stellar-mass black holes, a few to a few dozen times the mass of the Sun. When a massive star, like 8 times heavier than the Sun, burns through its fuel, it doesn't just fade away. It collapses, rebounds, and explodes in a supernova. What's left behind depends on how massive it was. Medium-big ones leave behind a neutron star, an ultra-dense remnant of a star. But if it were 20 times the Sun or more, it collapses all the way down into a stellar-mass black hole. Now, most of the stellar-mass black holes we've spotted are the clingy type, paired with stars. Some suck gas from their partner stars and light up in X-rays. We call those X-ray binaries. Thanks to those dramatic duos, we've found around 50 black holes in our galaxy so far. But scientists think there could be up to 100 million lurking quietly in the Milky Way. So yeah, we're surrounded. Next, there are supermassive black holes, the behemoths, chilling in the center of galaxies, millions to billions of solar masses big. Almost every big galaxy out there, including our own Milky Way, has a supermassive black hole. Our own galaxy's own heavyweight champ is Sagittarius A star. It tips the cosmic scales at about 4 million times our Sun's mass. That sounds huge, but compared to other galaxies, it's kind of a lightweight. Take the black hole in the galaxy Holmberg 15A, for example. It's got at least 40 billion suns worth of mass. Ooh, that's a big boy. How these mega monsters got so huge is still a mystery. Some faraway galaxies show us that supermassive black holes formed super early, like within the first billion years after the universe was born. One idea is that they started out as giant stars, collapsing in the early universe. Scientists know that these giants keep getting bigger by gobbling up smaller stuff, like stars, neutron stars, and even smaller black holes. And when galaxies crash into each other, their black holes can merge too, creating even bigger beasts. But the ones in the middle, the so-called intermediate mass black holes, are the unicorns. Rare, weird, and super hard to spot. That's why this new collision is such a big deal. It might finally be solid proof that these elusive in-betweeners are out there. So, how do we even know this record-breaking black hole crash happened? Well, it all started on November 23, 2023, when two ultra-tiny ripples in space-time passed through Earth. They were picked up by LIGO, the Laser Interferometer Gravitational Wave Observatory, which has two massive detectors, one in Louisiana and one in Washington. These places are like giant cosmic tuning forks, just listening for spacequakes. Each LIGO detector has two 2.5-mile-long arms in an L shape, with laser beams running down both sides. If a gravitational wave, like the one from a black hole crash, sweeps through Earth, it stretches space in one direction and squeezes it in another. That slightly messes with the timing of the laser beams. And even those microscopic changes are enough to signal that something huge just happened out there. Now, the signal they caught this time wasn't your everyday ripple. It was complicated because the two black holes involved were not only massive, but also spinning like crazy. And that's a big problem for astronomers. You see, when black holes spin super fast, the math behind tracking and understanding them becomes way messier and harder to pin down. So when scientists try to match this wild signal to their models, simulations of different black hole collisions, they didn't get one clear answer. Instead, they received a bunch of possible scenarios. What they do know is this: the black holes were huge, and one of them might fall into that mass gap zone again, that mysterious range where black holes aren't supposed to exist. But because the spin throws off experts' calculations, well, they can't say for sure. To get clearer answers, scientists need better models, and to build those, they need more examples of these rare, high-spin black hole mergers. Thankfully, that's not impossible. LIGO, Virgo, and Kegra have already detected around 300 black hole collisions since they started in 2015. And just in their latest run, 200 mergers. But here's the thing. This whole operation could be in danger. Unfortunately, LIGO is facing serious budget cuts, which might shut down one of its detectors. According to its director, without both detectors running, catching these once-in-a-universe signals could become near impossible. So yeah, we're getting better at hearing the universe whisper, but there's a chance we might have to start plugging our ears, just when it's getting interesting. Deep in space, something strange is stirring. Two black holes collide, sending ripples across the fabric of space-time. But there's a mystery hidden inside that gravitational hum. Is it evidence that black hole mergers may be far more tangled and thrilling than anyone ever imagined? Scientists may have just picked up something totally new, a third black hole hanging out in a black hole collision. Basically, when two black holes smash together, they make a kind of background hum. In one 2019 event, researchers noticed a weird signal inside that hum. It looked like a pair of black holes was speeding up in a way that didn't make sense, unless a third black hole was involved, hovering nearby and messing with things. It might be the first time anyone has found clear proof of a third compact object inside a black hole merger. When two black holes are stuck in a close orbit around each other, it's called binary black holes. Like regular black holes, these systems come in two main flavors, vanilla and chocolate. No, not really. One kind is stellar mass binary black holes. These form when really massive stars pass away in pairs. Ooh, how romantic. Or when two separate black holes end up capturing each other. The other kind is supermassive binary black holes. Scientists think they usually form when two galaxies crash together and merge. We got the first direct proof of stellar mass binary black holes in 2015 when LIGO detected gravitational waves from a massive collision. And it proved that not only do binary black holes exist, but that they also merge. Unfortunately, for supermassive black hole pairs, the evidence so far is indirect. Astronomers have spotted galaxies that look like they have two cores, which could potentially mean that each core has its own black hole. Others look like they might have two black holes hiding inside a single core. Some galactic centers even flash with periodic bursts of light. A giant object could be orbiting a black hole there. But there are also galaxies that show odd motion, which suggests a binary supermassive black hole. For instance, this galaxy has a black hole that seems to be moving in a strange way. It could mean it's part of a merger or a binary system. And then there's a quasar that looks like it has a pair of black holes orbiting each other every 1900 days. Binary black holes appear like this. When two galaxies smash together, their giant black holes in the middle don't usually crash right into each other. Instead, they just fly past on wide curves, unless something slows them down. That something is called dynamical friction. Basically, when a black hole passes near stars, it gives them a little slingshot boost, and in the process, loses some of its own speed. With more and more of these encounters, the black holes slow down enough to get stuck in orbit around each other, forming a binary. At first, this process works pretty well. But as the black holes get closer, they start to clear out the stars and gas in their path. With less material around to slow them further, they eventually stall. In the end, mutual gravitational attraction can make the black holes spiral together, but that only kicks in when they get very close to each other. And so, the big question is, how do they make that last jump? More stars or gas might drift close enough to the pair, and each time a star swings by and gets flung away, it steals a little energy from the orbiting black holes. Another possibility is the influence of dark matter, an invisible and hypothetical form of matter that does not come into contact with light or electromagnetic radiation. And there's one more dramatic option. What if a third supermassive black hole joins the mix? This could actually happen if the galaxy with the pair collides with yet another galaxy. Three black holes together create chaotic orbits, which open up two extra ways for energy loss. They wander through a bigger part of the galaxy, hitting and slowing down on more matter. Or their orbits get stretched into long ovals, and then, when they swing really close to each other, they lose extra energy through gravitational waves. So, has this third option just been confirmed? We'll talk about it a bit later. First, let's check out the life of a binary black hole in detail to understand this process better. The first stage is called the in-spiral. This is when two black holes are slowly circling each other while their orbit shrinks bit by bit. As the two black holes move closer together, they spin around faster and faster. This makes the gravitational waves much stronger. Eventually, they reach what's called the innermost stable circular orbit. It's basically the last safe orbit before they spiral in for good. After that, things speed up. The orbit eventually becomes unstable, and the two black holes plunge toward each other. When they collide and merge into one, gravitational waves hit their peak strength. This is the loudest, most dramatic part of the whole process. Right after the merger, the new black hole is kind of messy. It's stretched, distorted, and not stable yet. It goes through a phase called the ring down. During ring down, the black hole shakes off its uneven shape and settles into a smooth, stable form. While it's doing this, it gives off gravitational waves that mathematically sound like the fading echo of a struck bell. As the ringing fades, the waves get weaker and weaker. It means that the black hole is becoming calm, symmetric, and stable. Since 2015, when scientists first caught gravitational waves, they've logged about 300 black hole smash-ups, all thanks to the ripples, also known as gravitational waves, they've sent through space-time. By studying those ripples, astronomers can figure out how big the black holes are. Sometimes, the data even points to something called hierarchical mergers. That just means black holes merging, and then those new bigger ones merging again, and so on. It's like building up huge black holes step by step. Now, here's why that's important. Black holes born from stars can only be so big. When a giant star reaches the end of its life, it goes supernova. If it's under a particular mass, the outer layers blow off and the core collapses into a black hole. But if it's too massive, the whole thing just blows apart. No black hole left at all, just debris. So, if astronomers ever spot a black hole heavier than a certain limit, it means it probably didn't come straight from a star. Instead, it might have come from earlier mergers. Now, let's get back to the event we started our story with. It didn't break the mass limit. Actually, it was the opposite. One of the black holes was teeny by black hole standards, just 2.6 times the Sun's mass. That's so small, it's right on the edge of maybe not even being a black hole, but a neutron star instead. The other black hole was way bigger, around 23 solar masses. That size mismatch is super weird. Usually, binary black holes are way more equal in size. But here, one was a giant and the other was tiny. A team from the Chinese Academy of Sciences thought this odd pairing might mean something else was at play. They suggested the two black holes were part of a more complicated system, with a third, much larger black hole pulling on them while they orbited around it. To test this, they studied the gravitational wave data. If a pair of black holes is circling a third one, the signal should show a little extra acceleration along our line of sight. The team modeled how that would look and then compared it to the data they had about the event. And their model fit. The data pointed to an acceleration of about 0.0015 times the speed of light, with a 90% confidence level. That's a very strong hint that a third hidden black hole was really there. If that's true, it means black hole crashes aren't always simple two-and-done events. Sometimes they may happen in messier, more complicated setups. And there might be other strange cases hiding in the data, just waiting for someone with the right tools to spot them.
Scientists have thought for a long time that really huge black holes, those called supermassive black holes, sit in the middle of all big galaxies. But for some reason, try as they might, they couldn't find one in a galaxy called the Southern Pinwheel Galaxy, aka Messier 83, or M83, a spiral-shaped galaxy about 15 million light-years away from us. Still, researchers were sure it would be there. That was super confusing. And now, the super-powerful James Webb Space Telescope might have found a clue that there really is a supermassive black hole hiding in the middle of M83. Supermassive black holes eat up huge amounts of gas and dust, which makes them glow super bright. M83 didn't seem to shine, but could this glow be hidden by thick clouds of dust? Indeed, James Webb's amazing cameras have spotted clumps of special ionized gas that show up when a black hole is doing its thing, gobbling matter. So basically, the black hole could be playing hide-and-seek with us, and JWST might have just helped us figure out this long-standing mystery. So what exactly did scientists see? It was a glowing light coming from neon gas that needs a huge amount of energy, much more than what normal stars can make. This glow is a strong clue of a hidden active galactic nucleus. Even powerful star explosions, called supernovas, don't give off enough energy to make this kind of light. So, a supermassive black hole seems like the most likely reason. On the other hand, it's not the only possible reason. The glow might also come from shockwaves moving through the gas between stars, called the interstellar medium. To figure it out, scientists are going to take an even closer look using other powerful space tools like the Hubble Space Telescope, ALMA, and the Very Large Telescope. At the same time, this discovery shows how amazing the James Webb Space Telescope is. Apparently, it can find things in space that were safely hidden from our eyes before. Another example is an impossible black hole it helped to detect. On second thought, this discovery might not be as astonishing as it seemed at first. Let's figure out this mystery together. The thing is, astronomers thought they had found a super hungry black hole that was eating stuff 40 times faster than it should. And that was something that didn't make sense with the existing laws of physics. That black hole, called LID 568, was spotted with the help of the James Webb Space Telescope. It was from the early days of the universe, having formed just 1.5 billion years after the Big Bang. So, at first, it looked like the ravenous black hole was eating way too much and way too fast. That would have made it grow really big really quickly, which was surprising for such an early time in the universe. But now, after looking again with the Webb telescope, scientists realized they had been wrong all this time. The black hole hasn't been breaking the rules at all. What actually happened was that thick dust got in the way and made it look like it was eating more than it really was. Here's how black holes normally work. When stuff falls into them, it gets super hot and shines brightly. There's a rule called the Eddington limit, which tells us that the most a black hole can eat is based on how big it is. If a black hole tries to eat more, the light it gives off pushes the stuff away, so it can't eat anymore. Some black holes can eat a little more than this rule says. This is called super Eddington accretion, but not as much as 40 times. And the first guess said that LID 568 was doing just that, breaking this limit in a big way. And then, the new study, published in April 2025, showed that the black hole was actually eating at a normal rate. The mistake came from not seeing clearly because of all the dust in space. It blocks and scatters light, making it harder for us to see the black hole clearly. So, in the end, our hungry friend turned out to be not so hungry and pretty normal. Kinda disappointing, right? Scientists say that if a black hole is hidden by dust, like LID 568, you have to fix the light measurements for the dust to get the right size for the black hole. If you don't do that, you might get the wrong number for how big the black hole is, which also messes up the calculation for the Eddington limit. In their study, the team measured the black hole size using infrared light. This light is not blocked by dust as much as regular light, which is what scientists usually use. Thanks to this, they found out that the black hole was almost 1 billion times bigger than the Sun, and about 40 times bigger than the old guess. With this new, bigger size, they could fix the calculation for the Eddington limit, which made it clear that the black hole wasn't as hungry and bizarre as they thought. So, its feeding habits don't mean it's a super huge black hole growing really fast. Scientists have known that dust can mess up measurements of black holes, but they haven't always been good at fixing it when studying galaxies far away. This means that other black holes might have also been measured incorrectly, and people might have misunderstood them. The team's new way of measuring could help scientists learn more about these black holes that are hidden by dust in galaxies, especially the little red dots galaxies discovered with the James Webb Space Telescope. When scientists look at the first pictures of those faraway parts of the universe, they found something totally new. A bunch of tiny, super red galaxies. They named them the little red dots. There are hundreds of them. These dots only show up during a short time in the universe's history, when the universe was about 1 billion years old. And these little red dots are super confusing. They kind of look like two totally different things. Really heavy galaxies packed with stars, or modestly sized galaxies with a supermassive black hole in the middle. But one thing is clear. The typical red dot galaxy is tiny, only about 2% the size of our home Milky Way galaxy, and some are even smaller. So, what makes them shine? There are two main ideas. One of them claims that each little red dot is filled with a crazy number of stars, up to 100 billion, which is about the same number of stars as the Milky Way, even though a red dot is way smaller. Imagine standing in a huge, quiet room. That's like space near our solar system. Now imagine that same room completely jam-packed with the whole population of a very large country. Super crowded. That's what the inside of a little red dot might be like. It could be one of the most crowded places in the universe. Scientists aren't even sure galaxies this packed can really exist. Another idea is that these red dots are small galaxies with a giant black hole in the center. Scientists can spot signs of black holes by looking at how gas swirls around them. It gives off a special kind of light. And in many little red dots, they've seen those signs. Now, here's the strange part. The black holes seem way too big for such tiny galaxies. Usually, a black hole is only a tiny part of a galaxy's weight, about 0.1%. But in some of these dots, the black hole might be almost as heavy as the whole galaxy. That's really unusual, so scientists call those monsters overmassive black holes. And there's one more mystery. Normal black holes give off X-rays, and these ones don't. Even when scientists use special telescopes to look for X-rays, they couldn't find any. It's like these black holes are playing hide and seek, and we don't have the necessary means to find them yet. You're traveling through space, trying to get through an especially rough patch. You gotta dodge asteroids, space debris, wandering black holes. No, it's not an episode of a sci-fi series, at least not completely. For the first time ever, astronomers have found a black hole that's completely alone, drifting through space with no stars or planets nearby. This black hole is about 5,000 light-years away from us in our own Milky Way galaxy. Do we need to look for a hero with superpowers to save Earth? First things first, a black hole is a place in space where gravity pulls so much that nothing, not even light, can get out of this region. The gravity is so strong there because a huge amount of matter is squeezed into a tiny space. Supermassive black holes, hundreds of thousands to billions of times the mass of our Sun, are often found at the centers of galaxies. Most of them stay put or move at a very, very slow pace. But the newly discovered black hole is much weirder than anything we've seen before. First of all, it tries to avoid commitment. It's lonely, with no companion star or home galaxy. An even stranger thing is that it's zooming through space at a speed of 31 miles per second. What might be the reason for this speedy cosmic journey? Let's look at the following imaginary scenario. One day, a really massive star exploded in a supernova. It was the very star that formed our black hole. The resulting blast gave the new black hole a massive kick and sent it flying through the galaxy, starting its unbelievable voyage. Now, it's only one of a few possible explanations, but it sounds quite plausible. I bet you can't help but think, what if this wandering black hole decides to visit our solar system? Are we doomed? Scientists tell you to relax and breathe out. This black hole is very far away, and your chances of ever encountering it are infinitesimal, if any. Plus, this black hole is totally quiet and dark at the moment. One day, it might wake up and start glowing. It'll happen if it begins to eat something. In the near future, powerful new telescopes may find many more wandering black holes like this one. Usually, black holes are super hard to find because they don't give off any light. You can only detect them when they're eating nearby matter. That makes them glow brightly. Or when they have a companion star. In this case, it moves in a strange way, which gives away the presence of a black hole. But this newly discovered black hole is lonely, totally by itself. There's no glowing, no companion star moving hectically. So, how did scientists spot our cosmic wanderer? They used something called gravitational microlensing. That's when the black hole's gravity bends and magnifies the light from a star located behind it, kind of like using a magnifying glass, hence the name. This method allowed scientists to detect the black hole even though it was completely dark. All in all, black holes are fascinating things, and some of them are truly unique, like these biggest black holes ever found. You see, almost every galaxy has a supermassive black hole at its center. They're huge, with masses millions to billions of times bigger than our Sun. One of those is called TUN 618. It's a really huge and powerful black hole that's part of something called a quasar, a super bright spot in space emitting incredible amounts of energy. TUN 618 is very, very far away, about 18.2 billion light-years from Earth. And it's 40 billion times heavier than our Sun. There are also black holes that feed on their own kind. Black holes are known for devouring anything that gets too close. And this anything can include not only stars and gas, but also other black holes. Scientists witnessed a ginormous black hole at the heart of one galaxy being swallowed by an even larger black hole in another galaxy. It was the first time we detected such an event. The discovery was made using NASA's Chandra X-ray Observatory. One black hole weighs about 30 million times the mass of the Sun, while the other has at least 1 million times the mass of the Sun. Then, there is a bullet-shooting black hole. Apparently, black holes don't just swallow matter, they can also shoot it out. For example, astronomers studied one relatively small black hole, which is about 28,000 light-years from Earth and weighs between 5 to 10 times the mass of the Sun. And they saw how this black hole pulled matter off a companion star and then blasted some of it out in the form of huge bullets of gas. These bullets are super fast. They move at nearly a quarter the speed of light. Some black holes spin incredibly fast, twisting space around them at extreme speeds. One example is a black hole located in the constellation Agila, about 35,000 light-years from Earth. This black hole spins at a staggering speed of more than 950 times per second. If you could place an object on the edge of this black hole's event horizon, it would spin around the black hole at 333 million miles per hour. That's nearly half the speed of light. The smallest black hole discovered so far has been nicknamed the Unicorn. Located 1,500 light-years away from Earth, it's around 3 times the mass of our Sun. This makes it very close to the smallest possible size for a stable black hole. While black holes themselves are far away and difficult to study directly, scientists find new clever ways to study their properties right here on Earth. They've been able to recreate certain features of black holes in the lab. For example, black holes have a gravitational pull so strong that nothing, including light, can escape once it crosses the event horizon. To understand this better, researchers have created an artificial event horizon using fiber optics. They've also been able to simulate Hawking radiation, the kind that likely escapes black holes, by setting up experiments in the lab. These lab-created mini black holes help scientists understand the mysterious properties of real black holes. There are several types of black holes, and each of them is born in its own unique way. Primordial black holes are believed to have formed right after the Big Bang, when the universe was very young. Stellar black holes form when a massive star collapses in on itself. This causes a supernova, where the outer layers of the star explode into space and the core turns into a black hole. As for supermassive black holes, they're thought to have formed alongside the galaxies they're in. The size of the black hole is usually related to the size and mass of the galaxy. Despite what many believe, black holes don't roam the universe randomly, looking to swallow planets. They obey gravity like anything else in space. So, for a black hole to affect Earth, it would have to be very close, much closer than any black hole is to us right now. Even if a black hole the same mass as the Sun replaced our Sun, Earth wouldn't fall into it. The black hole would still have the same gravity as the Sun, and Earth would continue orbiting it just like it orbits the Sun today. It would get much colder though, so we wouldn't survive such a replacement in any case. But don't worry, our Sun will never turn into a black hole. It doesn't have enough mass to do so. Instead, in about 5 billion years, when the Sun reaches the end of its life, it will become a red giant star. After using up its fuel, it will shed its outer layers, creating a glowing ring of gas called a planetary nebula. What's left will be a cooling white dwarf star.
Scientists think there might be a huge onion chilling somewhere out there in space. Not an actual one, but it's something even crazier. These are stars stacked inside each other, layer upon layer. These fascinating objects, called gravastars, could even be cousins of black holes. But most importantly, they might hold the key to understanding some of the most mysterious puzzles in the universe, dark energy, and even other dimensions. Let's start with gravity. Over a century ago, Albert Einstein helped us understand how gravity works. Turns out, it's not just something that pulls things on Earth and makes apples fall on Newton's head. It's much wilder. It's about warping the very fabric of existence itself. Let's say you toss a heavy ball, like a bowling ball, onto the middle of your bed. What happens to the sheets? They dip, don't they? They stretch and sag around the ball. Now, if you roll a smaller ball, like a marble, across the bed, it doesn't move in a straight line anymore. Instead, it starts circling the heavy ball, rolling closer and closer as if the heavy ball is pulling it in. That's gravity. But instead of bed sheets, we're talking about the fabric of space and time itself, or space-time for short. Heavy objects like planets and stars make dents in space-time, and moons, planets, or even light move along these dents. Gravity is the curve that tells them where to go. In that case, you can guess that black holes are like the ultimate heavy balls. The heaviest, in fact. The gravity is so strong, it shrinks them, making them smaller and smaller. So tiny, they could fit in the palm of your hand, but with the mass of several suns. Some of them are like holding over 40 billion solar masses in your palm. It's ridiculous, but they basically create a bottomless pit in space-time with insane gravity. This area around them, called the event horizon, is the most horrifying thing ever. It's a point of no return. Once something gets there, it can never escape being eaten. When something falls past the event horizon, it can't climb back out, not even light. Which is why they seem like, well, black holes. But gravastars, they're something much weirder. Just like black holes, they're probably very compact. But instead of being tiny pits of endless gravity, they might have something wild at their core: dark energy. This is one of the universe's biggest mysteries. Dark energy, this invisible, mysterious something that seems to be pushing the universe apart faster and faster. It's like a polar opposite of gravity. While gravity tries to pull things together to slow down the expansion of the universe, dark energy is trying its hardest to make our world even bigger. Luckily, dark energy has been winning so far. Otherwise, we'd all be in some deep pit. But if we can explain the gravity with balls, then what exactly is dark energy? A force, an energy field. Something else? We have no idea. Scientists have seen its effects. They know that it's incredibly spread out everywhere, but they can't tell you what that thing even is. But if it's trapped inside of gravastars, maybe we'll finally discover the truth. This name stands for gravitational condensate stars. Gravastars were dreamed up by two physics professors, Powell Mazur and Emil Mottola, in 2006. They tried to think what else besides black holes could happen when a massive star collapses on itself. That's how they created this alternative. Think of it this way. Gravity pulls everything inward, making super heavy objects like stars shrink in size. The more the star shrinks, the denser it gets, and its gravity grows stronger. After some point, it can cross a critical threshold and become a black hole. But what if there was dark energy inside to counteract this? At the core of a gravistar, there could be a region filled with false vacuum or dark energy. This energy would push outward, fighting the gravity. It's like the unstoppable force meets an immovable object. Thanks to this, the star core doesn't collapse into a black hole. Sounds wacky. We don't know what dark energy even is, so how can it fill up anything? But luckily, even if scientists can't fully explain dark energy, they still have strong mathematical models to check how it works in our universe. So, they decided to test this theory. Here's where things get even weirder. The new theory says that gravastars might not be simple lone objects. Instead, they could be stacked one inside another. Each one is like a layer with its own dark energy bubble inside, surrounded by a thin skin of matter. The outermost shell would hold a smaller gravistar inside it, and that one could hold an even smaller one, and so on. It's like a series of balloons, one inside the other. The air pressure in each one of them is stable, evenly spread out. Thanks to that, none of them deflate. They coexist without one popping or collapsing the others. In the case of gravastars, the air is dark energy, and the rubber is the shell of matter surrounding it. It sounds crazy, but it actually makes this whole idea more realistic. A single gravistar might have a very thin shell of matter, but the thicker they are, the more likely it is to exist in a stable way. And finally, the coolest part about them is that they could explain one of the biggest mysteries of our world: how universes are born. When a star collapses into a gravistar, the matter could theoretically implode through the center and create a new dimension. This would connect these objects to the Big Bang itself. Some scientists even speculate that dark energy could be the energy exchanged between our universe and a child universe that's created from a gravistar. Of course, these are all just speculations for now. But where are all those gravastars? And how do we test this? Well, physicists aren't sure either. They're more of a what-if thing than an actual object that they discovered. Those two professors just tried to imagine what would happen if gravity and dark energy worked together like this. For now, the LIGO, a big observatory which detects ripples in space-time, hasn't found clear evidence of gravastars. Another problem is that gravastars would only be stable in specific cases. For example, if they spin too fast or their shell will be too thick, they might start to wobble or break apart eventually, though it could actually take billions of years. Plus, even if we don't see them right now, remember that this is exactly what happened to the black holes themselves. When Einstein published his groundbreaking theory of general relativity, another scientist, Carl Schwarzschild, took his equations and found a solution to them. And that's when he realized, if gravity becomes incredibly strong, the light wouldn't be able to escape, and this could create a sort of hole in space. Einstein even thought that this sounds too weird to be true. It took many years for us to confirm black holes' existence, and we finally took a photo of one just a couple of years ago. You might remember that blurry picture that blew up online? It was Sagittarius A star, an incredible supermassive black hole in the center of our galaxy, Milky Way. So that's why scientists approach gravastars so seriously. And since all the math checked out, which means that these objects are actually possible in real life. Now, we just need to see if they're somewhere out there. What's interesting is that they'd probably look like regular black holes. They could emit high-energy radiation as they consume matter. They might even produce something called Hawking radiation, a type of energy that escapes from black holes. In other words, it would be nearly impossible to tell the difference. But gravastars have a small trick up their sleeve. If their shell is transparent to light, they might bend light in a slightly different way than black holes do. So maybe if they checked the way light is bent around the mysterious object, they could spot the difference. And even if it turns out that gravastars don't exist in our reality, they're still valuable to science. They still taught us more about gravity, black holes, and the limits of relativity.
Now, scientists have a wild theory. What if our entire universe is actually inside a black hole? This is called the black hole cosmology. Some scientists have the idea that our observable universe and everything we see around us might be tucked inside a black hole, which exists inside another parent universe or even multiverse. And then this multiverse could be part of a bigger one, and so on. Kind of like a stacking doll. Sounds like pure science fiction, but this is based on some curious facts. When scientists create the timeline of our world, they say that everything started from a singularity. If you kept squeezing a giant ball smaller and smaller, at some point it would get super dense before it crushed. Well, it's hard to imagine, but in space, it's possible to squeeze a crazy amount of mass into a teeny tiny point. This point is called a singularity. The matter gets crushed into an infinitely small space, less than an atom, and it holds all the same mass of everything, while taking basically no volume. Inside this singularity point, things get so intense that the normal rules of physics just stop working. Everything we know, time, space, matter, breaks down and can't be applied anymore. Basically, what happens from now on is beyond our understanding. So, scientists say that this was the starting point of our world. When the Big Bang happened, it's like this tiny dot with everything inside it expanded to everywhere. This started forming the universe as we know it. And here's the thing. Scientists assume that singularity also exists deep within black holes. General relativity says that a black hole is born when something really big, like a huge star, collapses under its own weight. Gravity gets stronger the bigger the mass is. With a mass of a huge star, tens of times bigger than our Sun, this tiny point would have an unbelievable gravity. It's why it starts sucking in all the stuff around it and curves the fabric of space-time so much it looks like a hole in space. And this would be the center of a black hole. It's a dot where all these things fall into and get crushed into an infinitely dense point. So, could our universe itself be just a little singularity dot inside a huge black hole inside of another universe? Well, that would be wild. So, it's not that easy to compress something so much that it literally warps space-time. You'd need to squeeze it like crazy. If you wanted to make a small black hole like a human size, you'd need to shrink them down to the size of an atomic nucleus. If you want a black hole the size of a chickpea, you'd have to compress our entire planet to that. But our universe is 99% empty space. There are trillions of miles of just nothingness between the stars. If you were to pack all the matter in the universe together, the result would be surprisingly small. Everything around us, including galaxies, stars, planets, and dust, would only fill about 1 billion cubic light-years. It would be a cube about 1,000 light-years on each side. For comparison, our Milky Way alone is 100,000 light-years in size. That's how sparse the universe is. But at this density, it would also be very, very massive. The resulting mass would likely collapse into a black hole. And here's the wildest part. The resulting black hole would be roughly the same size as the universe itself. It would also have the same mass and energy, as well as the same average density. The size or radius of the black hole grows together with its mass. The more stuff it eats, the bigger it is. But the density works the other way around. The black hole gets less dense as it grows. For a size that big of our entire world, it would be pretty sparse as well. And it's not the only coincidence. We have this thing called the Hubble radius, also known as the cosmological event horizon. If we imagine our observable universe as a giant bubble, then think of its edge like the farthest part of the universe we can see. When you stand in a field and look around, trying to see as far as you can, your eyes will draw a circle. This is like that. There might be more beyond that point, but we'll never know. Beyond this horizon, the light from distant parts of the universe will never reach us. That's because light travels at a certain speed, and the space between us and those regions is expanding too quickly. It's like running towards something while super strong winds try to blow you away. Until we stay on Earth, we're cut off from those far-off corners forever. The black holes have something eerily similar called an event horizon, or the Schwarzschild radius. This is the point of no return. This is the imaginary line that's often depicted as a light contour around the black holes. Anything crossing an event horizon, falling inside, is lost forever. No light, no matter, no information can escape from there. Black holes' gravity is way too strong, so they're perfect space vacuum cleaners. And as we mentioned before, if we create a black hole the size of the universe, they would have the same mass and the same event horizon radius. Now, while some scientists think this could just be random coincidences, others believe it's a clue that our universe might actually be inside a black hole. The theory also suggests that our universe might not be the only one. It could exist in one of many black holes scattered throughout a large multiverse. In this crazy model, each one of them, both in our world and our parent world, could lead to its own universe, with its own set of physical laws and structures. Now that would be some weird chain. There's this theory that says that universes could be born inside of black holes, sort of. It's called the Einstein-Cartan theory. This idea talks about singularity as well, but in a different way. It says that instead of collapsing into an infinitely dense dot, the matter might create a wormhole. This is like a tunnel through space and time. This wormhole, also known as an Einstein-Rosen bridge, could connect two different places of our universe. In that case, one side of the tunnel is the black hole, and on the other side, there would be a whole new universe forming. So it could work like a teleport. As soon as you pass the event horizon, you travel to the new world. But in that case, there should be an exit. Some scientists made it up and called it a white hole. It doesn't literally exist, not as far as we know, but it could be possible somewhere on the other side. It would serve as an exit of a wormhole, an area where matter is always ejected instead of pulled in. So it's like you can't throw anything in there, it would get expelled immediately. That's all purely hypothetical, of course. All this stuff fits well into the concept of the Big Bounce. This idea says that instead of our universe beginning with a singular Big Bang, it bounced from a previous state of collapse. Remember the squeezed ball analogy? Well, maybe there used to be another universe ball that got super compressed to a minimum size before rebounding and expanding again. So instead of a universe born from nothing, we might live in one that's a cosmic recycling of another. There's also another version of this theory, sometimes called shockwave cosmology. The idea says that the Big Bang could have been caused by a boom inside a black hole, and this could create the expanding universe we see today. As the universe expands and the matter density decreases, the black hole would eventually transform into a white hole, the reverse of a black hole, where matter is expelled instead of pulled in. But even though we have all these interesting connections, they're not evidence. There are no experiments or observations that could prove or disprove these wild theories. So they all remain speculation for now. But at least it's fun to speculate.
Astronomers have discovered the most massive stellar black hole ever spotted in our home Milky Way galaxy. This newly found space monster is 33 times bigger than the Sun and sits 2,000 light-years away from us. Until recently, The largest stellar black hole found residing in our galaxy has been around 20 times as big as our star in terms of mass. As for the average stellar mass black hole, it's usually about 10 times as hefty as the Sun. Scientists from the European Southern Observatory's Gaia mission spotted the giant black hole after a star started to wobble while orbiting in that area. The black hole got the name of Gaia BH3. The proximity of this space object to Earth makes it the second closest black hole to our planet ever discovered. The nearest one is called Gaia BH1. It's hanging out around 1,560 light-years away from us. This uncomfortably close neighbor has a mass of about 9.6 times that of the Sun. It means that it's way smaller than the newly found black hole. Gaia BH3 is located in the Agila constellation. From Earth, it seems to have the shape of an eagle. Interestingly, astronomers didn't expect to find a high-mass black hole lurking so relatively close to Earth and remaining undetected for so long. Okay, we can probably admit that this stellar black hole is just a small fry compared to supermassive black holes like the one that dominates the center of the Milky Way. I'm talking about Sagittarius A star. This space giant has a mass of 4.2 million times that of the Sun. While a stellar black hole forms when a star collapses, supermassive black giants have their own ways of seeing the light of day. They are usually the result of mergers of progressively larger and larger black holes. We'll talk about that later. First, let's speak a bit more about how stellar black holes form. When stars near the end of their lives, they typically inflate, lose a lot of mass, and cool to form what we know as white dwarfs. Such massive stellar black holes as Gaia BH3 are believed to form when a star doesn't contain heavy elements and loses not so much mass over its lifetime. Such stars are called metal poor. Afterward, instead of cooling into a white dwarf, this star collapses into a black hole. The companion of Gaia BH3 is a very metal-poor star. It suggests that the star that collapsed and formed BH3 was metal-poor too. Astronomers know of about 50 stellar black holes in the Milky Way. Some black holes are larger than others. You see, the universe is filled with black holes. Some of them are sprinkled randomly throughout galaxies. Others, those giants we know as supermassive black holes, sit at the center of galaxies. While stellar black holes are usually just a few times bigger than the Sun, such space monsters can weigh from 1 million to 1 billion solar masses. But even though they're so much heavier than our star, they're packed into a relatively small area. On a cosmic scale, of course, the size of our solar system or so. Some astronomers think supermassive black holes could form by several stars colliding and collapsing at once, while other experts state that such space objects might have started growing several billion years ago. At first, a small seed appears somewhere out there in space, which then gradually increases in mass to form a black hole. This seed does it through the process of accretion, which basically means gathering more and more matter around itself. Besides the absence of any precise information about the formation of black holes, there's also the black hole information paradox. If a black hole has some mass, and as we know, these spaced objects have a lot of it, then, according to the first law of thermodynamics, it should have a temperature. And according to the second law of thermodynamics, it should also radiate heat. Stephen Hawking showed that black holes are supposed to emit radiation too. These days, this kind of radiation is called Hawking radiation. It should form at the boundary of a black hole, but after proving it, Hawking pointed out a paradox. If a black hole is capable of evaporating, some of the information it contains can be lost forever. The problem is that the information contained in thermal radiation emitted by a black hole gets degraded. It doesn't repeat any information about the matter swallowed by a black hole before. Such an irreversible loss of information contradicts one of the basic principles of quantum mechanics. Physical systems that change over time cannot create or destroy information. It means we must be missing something. Both physicists and mathematicians have tried to come up with different ideas. But they ended with pretty weird results. Some have even claimed that the universe could be holographic. It means that the universe that we know and love is actually the result of some mysterious interactions at the infinitely distant boundary. I told you, black holes are really strange. At the same time, we have definitely found space objects that seem to have the properties of black holes. For example, look at this image of black hole M87 star. It certainly looks like a physical object, but what if black holes don't exist at all? There's an idea that black holes are actually gravastars, a blend of gravity, vacuum, and stars. This theory was first proposed in 2001 by Emil Matola and Pavel O. Mazur. They hypothesized that at one point during the collapse of a large star, intense gravity might transform its matter into a new state. It's similar to what occurs when atoms are cooled to such low energy states that they start acting like a single superatom. When we speak of gravastars, a star might collapse to the point of the event horizon, or the point of no return, and then its matter is transformed into a new state. It exerts enough outward pressure to prevent the star from collapsing into a physics-defying singularity. In gravastars, an ultra-thin, ultra-cold, and ultra-dark indestructible shell surrounds heavily wrapped space-time. This new form of matter turns out to be very durable, but it's also a bit flexible, like a bubble. So anything that's trapped by the intense gravity of a gravistar and smashed into it gets obliterated and then assimilated into the shell of this bizarre space structure. One of the benefits of the gravistar theory is getting away with those messy paradoxes connected with information and singularities. But even though this idea sounds kinda cool, it doesn't explain the phenomena we observe. And we've definitely observed something that looks like black holes. On the other hand, look at this shadow. It isn't caused by the trapping of light in the event horizon. It's a slightly different phenomenon known as the gravitational redshift. It makes light lose energy when it moves through a region with a powerful gravitational field. So, potentially, it could be a gravistar. When the light emitted from the regions close to the alternative objects reaches our telescopes, most of its energy is already lost to the gravitational field, which causes the appearance of this shadow. And still, like with black holes, things get complicated when you add rotation to the equation. Many experts are sure that gravastars would not be able to remain stable during rotation. But wait, it gets even more bizarre. There are suggestions that the insides of gravastars could contain a series of thicker shells. Those are known as nestars, something like a matryoshka doll. Of course, these theories aren't perfect yet. Astronomers still have a lot of work trying to build functioning models. There's also a chance that both black holes and gravastars exist. But then, we've got another problem on our hands. How can we distinguish between the two? Some theories suggest that these different kinds of space objects should also emit very different gravitational radiation. It could allow us to figure out whether we're looking at a gravistar or a traditional black hole.
Black holes, the most terrifying, mysterious, and fascinating objects in the universe. Eternally hungry, they eat everything in their path and are constantly expanding. But how small and how big can a black hole be? Let's find out. It's not very easy for a black hole to be born. Most often they're just a result of a massive star ending its life cycle. If you take a star and squeeze it very, very hard, at some point it cannot withstand the pressure anymore. So it collapses and turns into a black hole. For example, we can create a black hole by shrinking the sun to about 1.8 miles, or squeezing the Earth into the size of a pea. Either way, in the end, we get a mysterious, dark object with incredible mass and gravity. Unlike stars and planets, black holes have no size restrictions. They grow when they eat the matter around them, but how much does their size vary? For example, can they be very small? Theoretically, yes. There may be black holes with a diameter of 1 atom, or even less. They're called primordial black holes. They may or may not exist, and if they do, they're probably the oldest objects in the universe, older than the atoms themselves. They would have formed right after the Big Bang, a long time ago when the universe still had an incredible density, a huge amount of energy, and in general was like a boiling broth. Any particle that was slightly denser than its neighbors could form a black hole. And the smallest of them would still weigh trillions of pounds. Those that were the size of atoms would weigh as much as a big mountain, and those that would weigh as much as the Earth could be a little bigger than a coin. But even if they exist, they're pretty harmless. The temperature in them would be so many times hotter than in our sun, so they would evaporate pretty quickly after their birth. Now let's check out the black holes we know and saw. The first ones are called stellar black holes. Usually, they weigh tens of solar masses, which doesn't seem like much until you remember that the sun weighs nonillions of pounds. Don't even try to imagine this number. It has 30 zeros. The smallest black hole known to us is about 2 to 4 times heavier than the sun. It's a lonely hole that wanders through space in search of prey. The one that's closest to us is called Gaia BH1. It weighs about 10 times more than the sun and can reach many miles in size. And the farthest one is called M33X7. It's somewhere around 3 million light-years away from us, and right now, it's eating a blue giant that's several times bigger than our sun. Now, let's move to the so-called intermediate mass black holes. You see, just eating a few stars isn't enough. To become larger in size, black holes must either absorb a lot of stars or, more often, merge with another black hole. One of the first intermediate mass black holes that we found was born this way. It weighs 142 times more than the sun. It's even larger than some counties on Earth. Recently, we discovered 2 black holes in a galaxy 17 billion light-years away from us. One day, they'll merge, but right now these guys are spinning around each other in a crazy dance. And while doing that, they release a crazy amount of energy. It may seem scary, but it's nothing compared to what comes next. Let's move to some serious stuff. Supermassive black holes. Giant, inexplicable monsters that are millions of billions of times bigger and heavier than our sun. But how did they become so huge? The universe is about 14 billion years old. The black holes grew very slowly, so they couldn't have time to eat so much matter or merge with each other so quickly. So maybe they were also born from the stars, but very, very big ones. Quasi-stars. To imagine their scale, let's take, for example, the red supergiant Stephenson 218. Compared to this star, our sun is just a grain of sand, even smaller. And Stephenson 218 would be a grain of sand next to a quasi-star. We don't know if they really existed though. They could have formed after the birth of the universe. They could be so big that their core collapsed under their own weight before they even formed. And if that's the case, a small black hole would have appeared in the center of this quasi-star. Now, the frenzied gravity of the black hole held the star together and ate it at the same time. The temperatures were huge, so the star remained stable, and they would live like this for millions of years until the black hole would grow to enormous sizes. Most supermassive black holes are located in the centers of galaxies. You might think that our galaxies orbit around them as we do around the sun, and that one day we will inevitably all be dragged inside it. But don't worry, that's not the case. Although these guys are incredibly massive, they're not very large in diameter. They can't swallow entire galaxies. For example, in the center of our Milky Way, there's a black hole called Sagittarius A. It has 4 million solar masses, but it's still quite small in size, only 17 times larger than the sun. And yes, it's still considered small. If we had replaced the sun with this black hole, it wouldn't even have reached the orbit of Mercury. Sagittarius A is actually pretty nice and calm. Yes, it still swallows giant stars, but it's definitely not a threat to us. But not all of them are like that. For example, a black hole in the galaxy BL Lacertae devours a huge amount of gas and dust. If we were somewhere near it, it would look 115 times larger than the Sun, and we would have burned up just getting close to it. Do you remember that first black hole we ever captured in a photograph? It's located in the Messier 87 galaxy, and it may look small and cute in the photo, but in reality, it's capable of absorbing our entire solar system up to the Orion Belt, and even further. Well, now that we've discussed the terrifying size of supermassive black holes, it's time to move on to the real titans of the universe. Ultramassive black holes. Terrifying, unimaginable giants. The largest objects that have ever existed and probably will exist in our world. Their masses exceed the mass of the Sun by tens of billions of times. Their gravity becomes so strong that they create quasars around them. Disks that shine brighter than thousands of galaxies combined. Remember, we talked about the fact that supermassive black holes aren't able to eat galaxies? Well, these guys devour not only their host galaxies, but literally everything on their path. The ultramassive black hole at the center of the galaxy OJ287 has 18 billion solar masses. It's so gigantic that it has another black hole orbiting it. It would also easily fit not one, but 3 solar systems inside of it. And now, finally, we've come to the largest object in the entire universe. TON 618, the almighty destroyer of worlds. A black hole that has eaten far more than one galaxy. Its mass exceeds 66 billion solar masses, and it could fit 11 solar systems inside of it. The quasar around TON 618 shines brighter than 100 trillion stars. Its light is so powerful that it has even reached us, even though we're at a distance of 18 billion light years from it. And the creepiest part is, this isn't even its true size. This is what it looked like around 10 billion years ago. Since TON 618 is so far away, its light reaches us for a very long time. That means what we see is how this black hole looked after the universe was born. But what does it look like now? We have no idea, but it's probably millions, billions of times bigger.
Black holes are massive, the densest objects in the universe. They have such a great mass that their gravitational pull doesn't let anything, even light, escape their clutches. But in this terrifying world of black holes, there are monsters that are in a league of their own. Recently, astronomers discovered a black hole that is 33 billion times as heavy as our Sun. This space giant sits at the center of a supergiant elliptical galaxy called Abell 1201, which is located 2.7 billion light-years away from our planet. This black hole is so large it was given a rare designation, an ultra-massive black hole. No wonder. It's more than 8,000 times heavier than the supermassive black hole at the center of our home Milky Way galaxy. This ultramassive black hole was the first one to be discovered with the help of gravitational lensing. This method is based on the fact that very massive objects such as galaxies bend the light from a more distant object, magnifying it. A great thing about this method of research is that it allows astronomers to study inactive black holes too. It could help us detect loads of new black holes beyond our universe. That's what the area surrounding our galaxy is called. Probably it would help us find some exotic objects we've never seen before. Now, let's speak about another awesome instrument that efficiently helps us explore space, the James Webb Space Telescope. When it stares at young galaxies, which would look like mere red specks to you, it sees an astonishing number of cyclones churning at their centers. Those are black holes. Interestingly, giant black holes were believed to be big players in early cosmic history. But James Webb regularly finds an unexpected number of these beasts. For example, using the telescope, astronomers have detected a supermassive black hole from when our universe was less than 600 million years old. In universe terms, it's just a baby. This is the most distant actively feeding supermassive black hole ever observed. It's located at the heart of its host galaxy called Sears 1019. The black hole is surprisingly small and not massive at all. It's actually one of the smallest found in the early universe. It's equal to approximately 9 million suns. It might sound like a lot, but in reality, supermassive black holes tend to grow to billions of times the mass of our star. There's another unusual thing about this find, and scientists are having a hard time trying to explain it. You see, it's supposed to take way longer than 600 million years for a supermassive black hole to grow to its full potential. The development happens when a black hole either feasts on surrounding matter or merges with a larger black hole. Even black holes similar to the one at the center of our Milky Way galaxy, which is almost 4.3 million times the mass of our Sun, are supposed to be seen in the more recent universe. Actually, scientists have long suspected that supermassive black holes probably existed in the early universe. But this theory has been proven only thanks to the JWST and its infrared eye. It's shown that the black hole Sears 1019 is actively munching on all the matter it can lay its hands on. Such feeding black holes are usually surrounded by swirls of gas and dust, falling inside them, called accretion disks. The gravitational force of a black hole heats this matter, and it makes the disk shine. And that's not all. Extra strong magnetic fields produced in this process channel the matter to the poles of the black hole. From time to time, this matter is released into space in twin, powerful jets. They move at a speed that is close to the speed of light, which generates incredibly bright light. Astronomers were watching the galaxy hosting the unusual old black hole as part of the Cosmic Evolution Early Release Since survey. They saw the galaxy as it was when our 13.8 billion-year-old universe was just 570 million years old. Besides the super old black hole, scientists spotted two other ones. Those probably appeared 1 and 1.1 billion years after the Big Bang. They also discovered 11 ancient galaxies that existed between 470 and 675 million years after the beginning of cosmic history. Now, how about having a look at the biggest black holes astronomers have found so far and finding out what would happen to Earth if one of them was to enter the solar system? NGC 6166 is a monster that has grown to have a mass of 30 billion solar masses. It's an elliptical galaxy that has an active nucleus at the center. It's also one of the most luminous sources of X-rays. The galaxy's supermassive black hole powers two symmetric radio jets in the opposite direction, which is the result of the infall of gas into its center. Another peculiar thing about NGC 6166 is that it shows a blue shift, which means it's moving towards us. Is it time to pack up and move out of our solar system? The next supermassive black hole is located in the constellation of Draco, approximately 10.4 gigalight-years from us. The mass of this supergiant is more than 30 billion solar masses. Besides being incredibly massive, the black hole is also really big. If it replaced our Sun, the diameter of this hole would extend to the orbit of Pluto. The next black hole is one of the most interesting on our list. It has a mass of 40 billion solar masses and is actually a blazar. It's the most energetic of all quasars, super bright distant objects. The blazar's luminosity is 300 trillion times that of the Sun, and more than 25,000 times as great as the luminosity of all 100 to 400 billion stars of the Milky Way galaxy combined. But since the distance to this quasar is about 12.1 billion light-years, we can't see it directly. But we know that the central black hole of the quasar consumes huge amounts of matter. About 4,000 solar masses of material every year. IC 1101 is a supergiant elliptical galaxy. It's the most massive known galaxy so far. Since this galaxy is elliptical, it isn't filled with gas. That's why the star formation in that region is very low. As for the black hole at the center of this galaxy, it lies in the mass range of 40 to 100 billion solar masses and emits clear radio signals. But wait for this champion. Astronomers have discovered a gravitational space wonder that has grown to really unimaginable proportions. The black hole I'm talking about is TON 618, and it's a mind-boggling 66 billion solar masses. Yep, we've got another ultra-massive black hole here. Imagine gathering all the stars in our home Milky Way galaxy and squishing the matter they're made of into one black hole. And it still won't be enough to create a TON 618. If this monster of a black hole replaced the Sun, its radius would be more than 40 times the size of Neptune's orbit. You know that black holes are incredibly dense, but it doesn't mean they're some kind of space predators roaming galaxies and munching on everything they come across. TON 618, for example, still has a whole galaxy filled with stars and other stuff happily orbiting it without getting pulled inside. So the perception of black holes as giant vacuum cleaners is wrong. In reality, it's incredibly hard to grow a black hole. Try and you'll see. And now, what if a supermassive black hole, like the one that dwells at the center of our home Milky Way galaxy, moved a bit closer to our solar system? The answer is simple. We'd be doomed. The distance between this huge thing and Earth would be several dozens of light years, and still, it would wreak total havoc on our planet. Earth, along with other objects making up the solar system, would be tugged into the black hole's orbit and doomed to spin around it for eternity. But you can relax and breathe out. Such massive black holes stay away from us at the moment.
Now really, an object weighing billions of times the mass of our Sun must be easy to find, right? Wrong. Unfortunately, it might not be that simple, like in the case with a missing black hole. But let's travel to the galaxy cluster Abell 2261, hosting a supermassive black hole at its center. Or at least, that's where it's supposed to be. The main problem is this giant space phenomenon is nowhere to be found. Now, supermassive black holes are mega monsters, churning slowly at the center of their home galaxies. They gather tremendous clouds of gas and dust around them, which makes them swell up to sizes the human mind can't begin to imagine. If a supermassive black hole, like the one that dwells at the center of our home Milky Way galaxy, moved even a little bit closer to our solar system, we'd be doomed. The distance between this huge thing and Earth could be several dozens of light years, and still, it would wreak havoc on our planet. Earth, along with other things making up the solar system, would be tugged into the black hole's orbit and doomed to spin around it for eternity or longer. Hey, who knows, right? So, it's good that such black holes stay away from us at the moment. So, let's see what happened to that runaway supermassive black hole from that gigantic cluster of galaxies around 2.7 billion years away from our planet. Scientists have been looking for it with the help of NASA's Chandra X-ray Observatory and Hubble Space Telescope. But so far, no result. The main problem with finding a black hole is that it's, black. And space is, you guessed it, black too. So there's no contrast whatsoever that could help astronomers spot the hole. But scientists haven't given up yet. After all, they have a lot of other technologies to find black holes, small and big, in the vastness of space. Some of these methods involve watching the stars orbiting black holes. Sometimes it's a fake gravitational wave signal, which is produced when two black holes collide. But the most reliable technique is watching dust and gas falling to their doom. The thing is, black holes are space objects with insane gravity. so regions of space surrounding them are usually a bit chaotic, gas and dust getting pulled into the bottomless abyss, compressing and heating up. In the process, it releases a flood of X-ray radiation, so astronomers look for extremely bright X-ray sources in the universe. Chances are those are the last gasps of giant clumps of material before they disappear into a black hole. Then, why can't scientists find such X-ray signatures left by the black hole in Abell 2261? One of the most mysterious things about its disappearance is that radio telescopes have spotted some signs of massive plumes of superheated material launched at one point within the last 50 million years. These plumes were most likely caused by a large black hole, which is nowhere to be found these days. So, at the moment, we can only play a guessing game. Maybe two medium-sized black holes collided, pushing the newly merged giant out of the center of the galaxy. The observations of the stars in that galaxy have shown a clump of dense material a few thousand light-years away from the galaxy's core. Maybe it's the runaway black hole, but disappointingly, no X-ray signals are coming from that clump. Or the hole might still be there in its rightful place, but it's, slumbering. If it doesn't get a fresh supply of gas and dust, it has nothing to feed on. As a result, it can't release a flood of X-rays. But again, the answer, do not disturb, the black hole is sleeping now, isn't very satisfying. Why isn't it getting its space food? What happened 50 million years ago? What is that clump of material speeding away from the galaxy center? So many questions, and no answers so far. At least, we know what black holes look like. Well, kinda. It's actually the shadow of a black hole's event horizon, visible against the glowing superheated material falling inside the hole. The first ever mugshot of a black hole appeared in 2019, but the data for its creation was collected in 2017. It took an international team consisting of more than 200 astronomers 2 years to assemble the image. We can admire this amazing space phenomenon thanks to a vast global network of telescopes called the Event Horizon Telescope Collaboration, or simply EHT. Why such a name? The thing is that the event horizon is a point of no return on the outskirts of a black hole. When something, for example, matter, radiation, or light, reaches this boundary, there is no way for it to escape the black hole's clutches. Anyway, to capture that very first image of a black hole, scientists created a virtual telescope that turned out as big as our planet by combining the power of 8 powerful radio telescopes. But it wasn't an easy feat. The researchers had to simultaneously point the telescopes in a meticulously planned order with the help of precise atomic clocks set on each telescope. Plus, to keep the chances of rain and bad weather to a minimum, they even constructed the telescopes in super dry regions, such as the Atacama Desert in Chile and the South Pole. On each observation day, the telescope gathers roughly 350 terabytes of data. That's 10 times the amount of data collected every day at the Large Hadron Collider. But let's speak more about black holes themselves. There are stellar black holes, smaller but even more dangerous than their supermassive peers. They appear when stars that have run out of their star food fall into themselves. If a star used to be big enough, it keeps compressing and compressing some more, and voila! A baby stellar black hole is born. But even if I call such a hole a small one, it's still 5 to several tens of times heavier than the Sun. Unlike their massive siblings, hypothetical mini black holes could be really tiny, not bigger than an atom. Even so, just one minuscule thing would have the mass of 1,000 SUVs. One theory claims tons of micro black holes could have been created right after the Big Bang and the beginning of the universe. Some scientists even go as far as to say that a couple mini black holes pass through our planet every day. There is a supermassive black hole smack dab in the middle of our galaxy, the Milky Way. Its name is Sagittarius A star, and it's 4.3 million times as heavy as the Sun. And nope, we aren't going to be pulled into this hole. It's more than 26,000 light-years from Earth, too far to have any influence on our planet. By the way, recently, astronomers have discovered that this supermassive black hole might be leaking, If it's true, it probably means that Sagittarius A star isn't a sleeping giant as previously thought. It might still be active, and the leakage recorded by scientists may be the hole hiccuping while swallowing clouds of gas. Maybe we should burp this baby? If you ever find yourself near a black hole, get ready that time will significantly slow down. It may work for you if you aren't eager to grow older. Just don't let yourself be tugged beyond the point of no return. Another danger of hanging around a black hole is that it might start behaving like a massive galactic volcano. From time to time, black holes flare up, but instead of spewing lava, they produce enormous amounts of energy, and it makes gaping holes in the surrounding material and gas. A short time ago, scientists discovered one of the largest craters in the universe. Radio and X-ray telescopes detected a supermassive black hole that threw a temper tantrum many years ago. It happened in a galaxy cluster about 390 million light-years away from Earth. The crater left behind, which was actually a hole punched in the cluster's hot gas, could fit 15 Milky Way galaxies. Okay, mind blown, I'm out of here. Black holes are some of the most enigmatic and sinister phenomenon in the universe. They can swallow up entire stars and planets, bending the very fabric of space and time. But what if Earth, our home planet, were to be caught in the grip of a black hole's event horizon? What would we see before the inevitable end? Well, let's have a look-see, okie dokie. So a black hole is like the bully on the playground. You avoid them at all costs. It's a region of space where gravity is so strong that nothing, not even light, can escape it. It's like Houdini in reverse. As with snowflakes, every black hole is unique. Each one has its own mass, spin, and charge. And they also come in different sizes, sort of like jeans. Petite, slim, regular, and husky, or something. Anyway, there are 4 sizes. The smallest black holes are the stellar mass kind. They're born when the massive star runs out of juice and folds in on itself. They're like the chihuahuas of the black hole world. They may be tiny, but they're feisty. They gobble up nearby matter like a hungry puppy. And even the smallest one is 3 times more massive than our Sun. Next up, we have the middle children of this cosmic family, intermediate mass black holes. They're too big to be born out of collapsed stars. Scientists believe that they may be created when several black holes merge into one. And even though they can't dominate galaxies, at least they can swallow up some nearby stars. Goody for them, huh? But do you know who can dominate a galaxy? The enormous monsters of our universe, supermassive black holes. They're the giants with masses ranging from millions to billions of times that of our Sun. And they play a crucial role in the growth and formation of their host galaxies. Finally, there are ultra-massive black holes. Trust me, you can't even imagine the size and mass of these guys. These cosmic eldritch horrors are extremely rare, but the ones we know can devour entire galaxies like Pac-Man. So, what happens if you get too close to a black hole? Or more like, what would you see in your last moments? Well, first, you reach an event horizon. It's like a point of no return, an invisible boundary that marks the edge of a black hole. And here's where things start to get really weird. For example, time starts to slow down. Not for you, for an outsider watching you from a safe distance. If you were falling into a black hole, you wouldn't feel any different. But if you were watching someone else fall into it, you'd see them slow down and eventually freeze in time, like in a paused video. As you get even closer, you would start to see some pretty mind-bending things. The gravity would cause the light around you to bend and distort, creating a sort of funhouse mirror effect. You might even see a halo of light around the black hole, known as the photon ring, or jets of high-energy particles spewing out from the black hole's poles. You can actually get pretty close to a black hole without feeling any major effects. It's only when you cross the event horizon that there's no going back. Your goose is cooked. After crossing this boundary, you'd be unable to see anything. For the person watching you from the outside, It would be as if you had suddenly disappeared. Meanwhile, you might start feeling a bit stretched out, like a piece of spaghetti. This is because the gravity is so stark that it's pulling you in different directions at once. There's even a scientific term for it, called spaghettification. We'll cover linguinification in another video. Now that you're inside a black hole, you're taking aim at the singularity. It's a point of infinite density in its center, where all matter is crushed down to a single point. It's like trying to fit an elephant into a tiny matchbox. Everything gets squished together until it's as small as it can possibly be. Which means it's time to wave goodbye, I guess. And if all that sounds scary, here's another fun fact. Black holes are not rare at all. Actually, there's one in the center of each galaxy, including our own Milky Way. So, does it mean that we'll eventually be sucked into it? And if so, how exactly would it happen? Well, let's see. Imagine a black hole approaching our solar system. At first, it appears as nothing more than a tiny speck in the distance. But as it gets closer and closer, its gravitational pull begins to wreak havoc around. Planets start to veer off course, asteroids are flung into oblivion, and comets are shattered into a million pieces. But just like waiting for the sausage to be served in a German restaurant, the worst is yet to come. Yeah, like that joke. Soon, it inevitably reaches the Earth. First, our planet's atmosphere would be pulled toward the black hole, triggering a massive windstorm. And there would be huge waves on the oceans, the water itself being distorted by gravitational forces. Imagine seeing seas and oceans getting stretched out. Earth's magnetic field is generated by the motion of molten iron in the planet's core. But now, the extreme tidal forces of the black hole would disrupt this motion, causing the magnetic field to weaken and distort. All this would cause massive earthquakes and volcanic eruptions as the planet's crust and mantle were pulled apart. All infrastructure and technology would be completely destroyed. Buildings, bridges, and roads would be torn apart. Okay, let's hit the pause button. Pretty horrifying, isn't it? Nah, but don't worry. You wouldn't have even seen that much, because you would have felt the effects of the black hole much, much earlier. Well, back to the future. We'll lose our magnetic field even before everything started to collapse. And this means not only that the weather and climate will become terrible, we'll also be exposed to extreme radiation. These gamma rays and the heat from the black hole could drastically change our planet. Say ta-ta to all our beautiful nature. At least misery loves company. We won't be the only ones affected by a black hole, which is probably even worse. As this beast engulfed the entire solar system, it would consume about everything. One immediate effect would be the disruption of the orbits of asteroids, comets, and all the other bodies. The planets would begin to deform and stretch, their surfaces warping like molten metal. The sun itself would be affected, its surface contorting like a glob of putty. And yeah, all this is scary even to imagine. But now, breathe and relax, because none of this will ever happen. This is the bright side, remember? Your infinitesimal odds of winning the big lottery are even better than the Earth ever being swept into a black hole. The nearest black hole to our solar system is called Gaia BH1. Discovered by scientists in 2022, it's found in our own Milky Way galaxy, about 1,600 light-years away from Earth. Gaia BH1 is about 10 times the mass of our Sun, which makes it a stellar mass black hole. It's not very interesting on its own, but its discovery has supplied valuable insights into the behavior of these cosmic monsters. But as you can see, even the closest known black hole is over 1,000 light-years away. They move very slowly, and they'll never get so close to our system to pose some kind of a threat. Hey, but didn't you say there's a black hole in the center of the Milky Way galaxy? Doesn't that mean it's going to eventually hoover up our entire galaxy, you may ask? Maybe not in that voice. Well, don't worry. The correct answer is no. The one in the center of our galaxy is called Sagittarius A star. You may remember it from that viral blurry photo that circled around the internet a few years ago. This black hole is indeed very massive and has a strong gravitational pull, like two eighth graders in love. However, it's still a small beam. It only affects objects that are close to it. The objects in the galaxy are all too big and move too fast to be pulled in by black holes. Nevertheless, they're still fascinating objects to study. Scientists are still trying to unlock the mysteries of black holes. And even though they'll never be dangerous to us, they're still a huge reminder of the incredible power of our universe. Now I think I'll turn my attention to the incredible power of chocolate.
NASA has recently revealed some eerie cosmic sounds that go against the popular misconception about the muteness of space. This discovery proves once again that the universe is far from silent. The revelation came from the Perseus galaxy cluster, located 250 million light-years away from Earth. There, NASA uncovered an unworldly howling coming from the supermassive black hole at its center. This discovery isn't super fresh. It was made in 2003. It marked the first time scientists detected an acoustic phenomenon from such a distant source. Sadly, the sound was not something you would be able to hear. Its frequency was just too low for the human ear to register. The lowest pitch the human ear can perceive is 20 Hz, 20 cycles per second. But the sound emitted by the black hole is a B-flat, 57 octaves below middle C, with a frequency of 10 million years. But NASA brought it to the realm of human hearing in 2022, turning that invisible sound into something you could actually experience. It was a breakthrough of cosmic proportions when NASA revealed that sound waves could travel through space, specifically through the medium of the Perseus galaxy cluster. This medium is a hot, dense gas, something far more substantial than the empty vacuum between galaxies. That's how sound waves manage to travel there. Those sound waves produced by the supermassive black hole at the center of Perseus resonate through the hot gas as ripples. It's like how sound travels through water here on Earth. The thing is, space is indeed a vacuum, which means that sound cannot travel through it, in the traditional sense. But the gas surrounding the black hole in Perseus provided the perfect environment for sound to travel. The black hole's powerful jets create ripples, sending vibrations through the gas. And NASA scientists have identified those vibrations as a type of cosmic sound. Previously, it was totally invisible and unhearable. But now, for the first time, astronomers have helped it to take a form humans can hear. To give us a sense of how deep this sound is, NASA raised its pitch by 57 octaves so that it could finally be audible to the human ear. The result is a haunting, bass-heavy hum. It feels as though it is resonating from the very core of space itself. What NASA did is called sonification. This process involves mapping the characteristics of the data to audible sound. As a result, we can experience something that is otherwise beyond our perception. See those brighter areas of the cluster? They produce louder and higher-pitched tones. The sonification of the Perseus black hole isn't just a scientific discovery. It has allowed us to see, or should I say, hear, the universe in a completely different way. NASA has used this technique on several different space objects, including stars, nebulae, and galaxies, giving us a glimpse into the various ways space can sound. One of the coolest NASA's sonifications is Cassiopeia A. It's the remains of a star spotted as a supernova more than 300 years ago. Located around 10,000 light-years away from Earth, this shattered remnant of a once massive star has a neutron star at its core. And it's the youngest neutron star in our galaxy that we know about. To perform the sonification of Cassiopeia A, NASA took the data captured by the Chandra X-ray Observatory and translated it into sound. Starting at the center,
A triangle-shaped tone marks the location of the neutron star. Then, the sound spreads outward, which represents the expanding debris field. That's when the pitch rises and the tones become brighter. The sound grows louder and seems to mirror the outbursts of the supernova and the formation of new elements. The Tarantula Nebula, located in the Large Magellanic Cloud, is a hotbed of star formation and one of the most active regions in the universe. Astronomers have been studying this nebula for a long time to learn more about how stars are born and evolve. So, no wonder that NASA scientists have been doing their best to translate the data from the nebula into sound. They've been mapping brightness and pitch to various features in the nebula. So, airy, synthesizer-like tones represent the chaotic and hot gases surrounding the most massive stars. And the cooler gases that are forming new stars have soft, low notes. Piano-like tones correspond to the brightest stars. And the central cluster of stars sounds like a rain stick. Interestingly, NASA's investigation into the sounds of space doesn't just involve cosmic phenomena. It's also based on the experiences of astronauts, and some of them are truly eerie. After all, space exploration is always filled with unexpected surprises, and sometimes those surprises come in the form of strange noises aboard spacecraft. One such incident occurred aboard the International Space Station, when astronaut Butch Wilmore reported hearing a strange noise coming from Boeing's Starliner spacecraft. By that time, this spaceship had been docked at the station for almost 3 months. The Starliner had just completed an 8-day mission that went awry. The technical issues have been plaguing the spacecraft ever since. Wilmore described the sound as a pulsing noise, similar to a sonar ping. It was coming through the spacecraft's speaker system. This strange noise made Wilmore contact NASA's Johnson Space Center in Houston. Of course, Mission Control immediately began investigating. They were able to listen to the audio inside the Starliner. Wilmore even held his microphone up to the speaker so that NASA could hear it more clearly. The people in charge of the investigation finally identified the source of the noise. They announced there was an audio configuration issue with the ISS's complex communication system. The thing is, this system connects numerous spacecraft and modules, and such configurations can sometimes lead to strange noises. NASA reassured everyone that such an issue wasn't really unusual. At the same time, they encourage astronauts to report any unexpected sounds they come across. At the same time, this incident was just another proof of how tricky it is to maintain advanced spacecraft systems in orbit. The Starliner had already faced serious delays and setbacks, and every new issue added extra pressure. Everyone was worried about the spacecraft's safe return to Earth. In any case, it's not the only incident involving eerie space sounds. In 1969, during the Apollo 10 mission, astronauts heard something truly bizarre while orbiting the Moon. Now, Apollo 10 was a dry run for the historic Apollo 11 moon landing. This mission involved astronauts Thomas Stafford, John Young, and Eugene Cernan. They were testing the systems of the lunar module. Everything was going smoothly, and then they started passing behind the Moon. In that region, radio signals from Earth couldn't reach them. At that point, they all started hearing a strange, high-pitched whistling sound. It was coming through their headsets. The origin of this noise baffled the astronauts since it wasn't supposed to exist in the near vacuum of space. At first, they simply joked that it sounded like outer space music. But in reality, the situation was quite unnerving. The astronauts were on the dark side of the Moon, far away from Earth and any help. And now there was also that eerie, mysterious sound they couldn't explain. At the same time,
NASA was super worried about astronauts' health and mental condition. So the crew didn't immediately report the noise to mission control. But after they returned to Earth, NASA engineers thoroughly investigated the phenomenon. They came to the conclusion that the sound had most likely come from the spacecraft's communications system. The reason could be the unusual circumstances of the mission. After all, the spacecraft was kinda cut off Earth. The moon was between it and our planet. Still, even after this extensive analysis, the origin and nature of the whistle is still a great mystery for many people. Anyway, all these new discoveries and old cosmic puzzles prove that the universe is far from silent. It hums, roars, whispers, and reveals the mysteries of the cosmos one note at a time. In the future, as our technological abilities continue to evolve, NASA's work with sonification and its study of strange astronaut experiences will likely lead to even more awesome discoveries. And if we listen more closely, we may find that the universe is much more talkative than we think.
Black holes, an enigma that has puzzled scientists and captivated our imagination for decades. But what's hiding inside of a black hole? Is it a void? A bottomless pit? A parallel universe? We don't know for sure yet, but scientists might have some ideas. So let's hear them out. Picture this. In the vastness of space, there's a supermassive star, shining bright like a diamond. But like all good things, this star's party can't last forever. Eventually, it runs out of fuel and goes out with a bang. Quite literally, the star collapses under its own gravity, creating an implosion. Now, this collapse is so intense that it creates a bottomless pit in space, like a sinkhole. This is what we call a black hole, the ultimate no-escape zone, sucking up everything in its vicinity, including light. Imagine yourself approaching a black hole. The black hole itself doesn't emit any light, but you can notice a dazzling display of cosmic fireworks surrounding it, the accretion disk. It's like a celestial carousel of gas and dust swirling in a mesmerizing dance around the black hole. The incredible gravitational forces pull all this material from their surroundings, creating this celestial furnace. Of course, it's very unlikely that you would have survived in this place. Temperatures here soar to millions of degrees. Also, it's constantly dazzling X-rays and high-energy radiation that can be detected from telescopes on Earth. But let's imagine that you did survive, somehow. As you get closer, you notice a mysterious boundary looming ahead, the event horizon. It's a point of no return, beyond which the laws of physics seem to go haywire. Now you're stuck in a space traffic jam, and no matter how hard you hit the gas, you're going nowhere. Once you cross this threshold, not even light can escape. And now, you inevitably fall into a black hole. What do you see around you? According to the genius physicist Albert Einstein, space and time aren't separate entities, but rather intertwined in a fabric called space-time. It's like a cosmic trampoline that can stretch and bend if you place something heavy on it. And black holes are super heavy, which is why they distort this trampoline in the most extreme way possible. So when you venture close to a black hole, you're in for a roller coaster ride. The curvature of space-time becomes so intense that it's like a whirlpool pulling everything in, even light itself. Everything around you looks like a space funhouse with distorted colors and rays of light that keep shifting. All this makes you feel like you're doing the moonwalk on a treadmill. Also, the curvature of space-time around a black hole is so extreme that it creates a phenomenon called time dilation. Time near a black hole moves at a different pace than in the rest of the universe. The closer you are to the black hole, the slower time ticks, like a slow motion effect. And the deeper you fall, the weirder things get. The laws of physics seem to break down before your very eyes. But suppose you somehow manage to survive all this madness. Where exactly are you falling? What awaits you on the other side? Is there even an other side? As you venture deeper into the celestial maelstrom, you reach an elusive and mysterious point called the singularity. It's the heart of a black hole, a place where all matter and energy are crushed into a single, unimaginably dense point. Imagine cramming masses of entire stars to something that is essentially a pinprick. And now that you're here, forget about the usual rules of physics. Welcome to a new realm, where the known breaks down and the unknown takes over. So, what does this unknown look like? Well, there are a couple of theories. First off, it could be a gateway to other dimensions. What if there are multiple universes hiding within black holes, like nesting dolls? According to this theory, the interior of a black hole could be a portal to a parallel universe with its own set of physical laws and possibilities. This parallel universe could be drastically different from our own world. What a mind-bending idea! Or what about wormholes? Imagine black holes forming a space subway system, connecting different regions of space and time with each other. These theories suggest that the extreme gravitational pull of a black hole could create a wormhole, a tunnel that could transport you to another galaxy, or even to the past or future. It's like finding a secret passage in a video game. That's not all. Some scientists propose that inside a black hole, we might find some exotic matter, some strange matter with weird properties or negative energy density. If that's the case, this would defy our understanding of the universe. And finally, one of the most mind-bending theories is that a black hole could actually lead to a white hole. Imagine, as you fall further, you suddenly find yourself in a blindingly bright space show. You're in a white hole. This is a fountain that's spewing out matter, energy, and information into the universe with reckless abandon. The birthplace of new universes. You see, while black holes are known for their event horizon, white holes have an anti-event horizon. With black holes, everything can enter and nothing can come out. With white holes, it's the other way around. They repel everything. White holes are hypothetical objects. Their existence hasn't yet been proven. But if it turns out that they exist, they could be connected to black holes. It makes sense. Black holes suck everything in, and white holes should take their matter from somewhere. And all this matter and energy coming out of the white hole could potentially form new universes. Together with black holes, they could form a universal cycle of creation. The end of one universe leads to the birth of another. All these theories are beautiful and fascinating, but here's the catch. There's still no concrete evidence of any of them. Black holes still remain one of the biggest mysteries of our world. Unfortunately, studying these mysterious beasts isn't easy. They're super elusive, and this is one of the biggest challenges for scientists. Black holes don't emit light, so they can't be seen directly. They're essentially invisible to telescopes that rely on light, making them incredibly difficult to observe. That's why scientists have to rely on things like X-ray emissions, the effects of a black hole's gravity on nearby objects, and other clues. They're also very unpredictable. For black holes, physics is like a fun playground. They warp space and time around them, which makes it difficult to predict and understand their behavior. But don't worry, space enthusiasts. The future of research in this field is as promising as ever. We've already made incredible discoveries. For example, in 2019, we captured the first ever direct image of a black hole. This is a central black hole of the galaxy Messier 87. A few years later, We also took a photo of a black hole in the center of our own galaxy, the Milky Way. This one is called Sagittarius A star. All this has opened up new avenues for research. And these aren't the only cool things we've discovered in recent years. Let's take gravitational waves, for example. You know how rocks leave ripples after falling into water? Well, gravitational waves are ripples in the fabric of space-time. They carry clues about the most cataclysmic events in the universe. They've allowed us to listen to the universe, unveiling previously hidden phenomena and events. And all these observations provide us with a new way to study black holes. We constantly make new advancements in technology. The James Webb Space Telescope will provide us with even more detailed observations and insights into the mysteries of black holes. There's still so much we don't know, but that's the beauty of science, the thrill of the unknown, and the curiosity that drives us to explore the mysteries of the universe. So, let's keep peering into the cosmic abyss on the thrilling quest to unlock the secrets of our world.
Ever wondered what it would be like to hear the sound of a black hole? NASA's got you covered. Here is a screaming black hole. Screaming in space? I thought in space no one can hear you scream. Well, let me explain. Using a telescope, NASA examined the movements of hot gas in a cluster of galaxies in 2002. Then they converted what they found into a sonification. The sound, how can I put it politely, wasn't appealing, but that's okay. After all, you're able to hear the noise hot gas produces in a cluster of galaxies 250 million light-years away. Hey, how would you like to hear the sound gas produces right here on Earth? Never mind. Sound waves already existed over there in the gas cluster, so experts just rescaled them to the range of human hearing. This is how they converted the input coming from the telescope. The principle is universal. In our atmosphere, we can hear stuff because pressure waves move through a medium like liquid or gas. Sound waves in these galaxies can also move because they're surrounded by gas. What does it have to do with black holes? Well, the thing triggering those pressure waves in the cluster is a giant black hole. To be more precise, it's a supermassive black hole that weighs millions of times more than the Sun. Wow. Experts still don't fully understand the relationship between supermassive black holes and the clusters surrounding them. They only know that these two evolve together. They're interrelated. The cluster feeds the black hole with new material and so on. And in return, the black hole heats the cluster. That's all we know. Now, this made me wonder how large the biggest black holes are. There are 4 types of black holes: stellar, intermediate, supermassive, and miniature. Naturally, the biggest ones fall into the category of supermassive. The largest black hole in the universe we've discovered so far is about 66 billion times larger than the Sun. It's one of the brightest objects in the universe. Astronomers keep scanning space and finding new black holes. But have you wondered when the first black hole was spotted? It was discovered by different researchers independently in 1971. Scientists first confirmed that these objects were formed from the remnants of massive stars. After a black hole appeared, it then consumed all the nearby objects. Here is a quick recap of how these space objects work. Their gravitational force is super strong. Nothing can escape a black hole after crossing the event horizon. Black holes eat everything, just like me. I mean, even light gets trapped inside them. What's even cooler/scarier is that the laws of time and space become distorted there. If you were falling into a black hole, you would realize that time slows down there. Einstein explains this in his famous general relativity theory. In very, very basic terms, time gets affected by how fast you are moving at extreme speeds. NASA has discovered a rapidly growing black hole, but don't worry, the world isn't in danger. This black hole has been in front of the eyes of astronomers this whole time. It's in a region of a well-studied sky field. Astronomers say that this hole formed 750 million years after the Big Bang, the birth of our universe. So why are black holes so bright? Well, that's a bit ironic. When I defined this space phenomenon, I said that black holes were so dense that even light got trapped there. But ask any astrophysicist, and they'll confirm that black holes are among the brightest objects in space. That's because black holes don't exist alone. They sit at the centers of galaxies and are usually surrounded by clouds of hot gas. And these clouds create cosmic auroras around black holes. I must mention, though, that you can't see a black hole directly. What you see is actually the effects it has on its environment. For instance, you can see space objects being ripped apart by a black hole. Remember when the first time ever silhouette image of a black hole was shared with the public in 2019? Proof, you fellas. You wouldn't really see the black hole if there was no orange ring. Why is the ring orange and not green or purple? The dark shadow inside is the shadow of the black hole. The glowing orange of the bright ring in the image isn't the real hue of the gas. I'm a little heartbroken here. It's a representation picked by researchers to depict the brightness of the emissions. A scientist explained that yellow is the most intense emission, red is less intense, and black has little or no emission at all. In the optical range, this ring would likely seem white, perhaps tinged with blue or red. Now, spaghettification is a real word. That's an astonishing ability black holes have. If a giraffe fell into a black hole, it would stretch into a long spaghetti-like strand. On Earth, a giraffe's legs are closer to the center of Earth, so they're more powerfully attracted to the surface than the animal's head. This rule works in the animal's favor on Earth, but would work against it inside a black hole. In a black hole, there's extreme gravity. The closer the giraffe's legs got to the center of the black hole, the more the pull of gravity would stretch them. And the closer to the center the giraffe got, the faster its legs would move. But the top half of the giraffe's body would be farther away, so it wouldn't move toward the center as fast as the legs. Here comes the spaghettification. Can we have meatballs with that? No? Okay. The only difference between a black hole and our Sun is that the center of the hole is made of super dense material. It provides the black hole with a strong gravitational field that can trap everything, including light. This is why we can't see black holes. Did you know that, theoretically, you could turn anything into a black hole? For instance, if you shrank the Sun to approximately 4 miles across, you would compress the matter inside to an extremely small size. This would make it so dense that our star would turn into a black hole. You could do the same with a planet or even your own body. Is there something called a white hole, or is it just a myth? White holes exist in theory. Hypothetically, they function in the opposite way to black holes. Nothing can enter them. Physicists think of black and white holes as yin and yang, or two sides of the same coin. For them, a white hole looks exactly like a black hole, which makes different things come out of it. But the existence of white holes hasn't been proven yet. And how about wormholes? There are so many movies about black holes and wormholes. How many of them are based on reality, and how much is fiction? Some people believe that black holes function like wormholes. You go inside and exit in another part of the universe. Since we still have a lot to learn and discover about physics, no one can prove this theory is wrong or right. Astrophysics says we need to have a solid theory that unifies general relativity with quantum mechanics. Black holes are among the largest structures in the universe, but there might be tiny specimens. The mass of the smallest black hole we know about is only 3 times greater than that of our Sun. Now, apparently, black holes can vanish. Stephen Hawking developed a theory of Hawking radiation. According to it, radiation decreases the mass and rotational energy of black holes, and ultimately they evaporate. This process occurs very slowly, though, if we're not talking about small black holes. Astronomers have discovered an elusive black hole in the neighboring galaxy. What makes this one special is the fact that it's the first dormant stellar black hole outside of our galaxy. This type of black hole is hard to observe because such holes don't interact much with their environment. They don't emit as much radiation as other black holes. Well, back on Earth, what about sinkholes? Well, different physics. Yet, if you cross the event horizon, your whole car can disappear. Whoops!
Here's something cool that scientists have discovered recently: Schrodinger's black holes. Yep, the scariest objects in our universe turned out to be even more terrifying. Now, we know that they can also exist in many states at once. But what does it mean? Let's find out. Black holes are mysterious titans of our universe. Sometimes it feels like the more we learn about them, the less we know. We discovered them quite recently, in the 20th century, and since then, we've been finding various black holes all over the universe. Their sizes range from the size of a small town to horrifyingly unimaginable. But their most important feature is probably their huge mass. And that's where a recent study comes to play. Scientists have discovered that black holes have very unusual quantum properties. They found out that each black hole can be both large and small, light and heavy, no longer living and alive. Well, maybe except for the last part. Let's hope that there aren't actually any living black holes. That would be great. But the main point of the discovery is that each black hole can be in all possible states at the same time. It sounds weird, doesn't it? What is it actually supposed to mean? Well, the ability to be everything at the same time isn't a new concept in science. This is what physicists call a superposition, or, to put it simply, a state of uncertainty. Quantum physicists discovered this first in tiny quantum particles. They noticed a very strange thing. As long as we don't observe a particle, it literally exists in all states at the same time. And only when we start interacting with it, for example, looking at it, measuring it, or just doing something, only then does the particle decide what state it should be in. Here's an example of this. Imagine that you have a ball in a box. You don't know what it looks like, and the thing is, as long as it stays in the box, the ball is all colors at the same time. Only when you take it out of the box does it finally choose one color. All this happens instantly, so you don't notice it. For you, the ball has always been blue. Sounds pretty scary, right?
What?
And it raises a lot of questions. For example, how do these particles understand that we're observing them? How do they decide which state to be in? And what does our world really look like if we only see what is shown to us? Of course, this discovery caused a huge stir in the scientific community. No wonder, it does sound a bit unusual. That's what physicist Erwin Schrödinger also thought at the beginning of the 20th century. The ideas of quantum theories seemed delusional to him. That's why he decided to challenge them. He conducted a famous experiment. You've probably heard about it, even if you don't know anything about science at all. Yep, the infamous experiment with Schrödinger's cat. So, what was the point of the experiment? First of all, we have a box and a cat. In the box, there's a container with toxic gas and a special mechanism. Every hour, there's a 50% chance that this mechanism will either open the gas container or not. If it happens, the poisonous gas will be released and the poor cat won't make it. If this doesn't happen, the cat will remain alive and well. Don't worry, this was a purely hypothetical experiment. No cats were harmed in the process. But let's imagine that we did lock a cat in a box and waited for an hour. It's time to check the result. And here's where we get close to the most interesting part. How do you think this situation would end in our regular world? Well, probably within an hour, the container would either open or not, and that would be the moment sealing the cat's fate. After that, we just need to open the lid to find out the answer. But in quantum physics, everything is much stranger. According to it, until we open the box, the cat inside would be both alive and not alive at the same time. In other words, the universe itself doesn't know what to do with this cat. As if the poor animal is on the verge of two worlds inside the box. And when you open the lid, the universe will select a random result of the experiment. So why do we do all this to a poor kitty? Well, initially, Erwin Schrödinger wanted to show how stupid it all sounded, but then he accidentally proved that quantum physicists were right. The situation turned out to be pretty funny. It went like this. Ha ha ha, these quantum physicists have no idea what they're talking about. According to their logic, the cat in my box should be both alive and not alive at the same time. Wait, hold on. Uh-oh. They're right. Schrödinger received the Nobel Prize in 1933, even though it wasn't for this discovery. And in 2022, 3 more scientists received the Nobel Prize for another discovery in this field.
Thank you.
These scientists were Alan Aspect, John F. Clauser, and Anton Zeilinger. They got it for their experiments that involved entangled quantum states. What does all this tell us? Guess now we'll have to look for explanations in some kind of quantum mechanical magic. Unfortunately, humanity isn't developed well enough to test any of these theories, yet. But we have many cool assumptions. For example, the theory of parallel universes is one of the attempts to explain this phenomenon. Remember that ball in the box? Basically, according to the theory of the multiverse, there's an infinite number of different realities. So if you don't know what the ball looks like, it kind of exists in this interdimensional, uncertain state. But when you open the box and look at the ball, you get transported to a random reality. For example, to the one where it's blue. It sounds pretty incredible, but still exciting. Alright, but why do we need all this info now? Why is it connected to the recent discovery? You see, scientists thought, if teeny tiny particles in our universe behave like this, then what about some giant space objects? And so, they decided to direct their devices not into the microcosm, but into distant space. American and Israeli theoretical physicist Jacob Bekenstein was the first to suggest that black holes may have the same weird properties, but this theory had to be tested. The research itself was aimed at finding a connection between quantum particles and black holes. The researchers created a computer structure in which they placed a simulated quantum particle directly outside a giant simulated black hole. And in the end, this analysis showed that, yep, black holes could also exist in several states at once. For example, they can be incredibly massive and at the same time have no mass at all. And each of these mysterious space gates can have several masses at the same time. The modeling showed that these superimposed masses were, in fact, in certain determined bands or ratios, as predicted by Bekenstein, said the physicist Magdalena Zeik, referring to the study. It's not really clear yet what it all means, and this discovery alone hasn't brought us much closer to understanding how our universe works, or what happens inside black holes. We have realized only one thing. Everything around us is much more complicated and more fantastic than we think. Who knows? Maybe black holes are portals between these parallel universes. At this stage, it's impossible to disprove this. In other words, the universe has once again shown us that it is stranger and more mysterious and fascinating than we could imagine. Let's hope that in the future, we'll be able to understand at least a bit of what's going on in it.
Imagine a black hole, a terrifyingly dense space object pulling inside everything that comes too close. Nothing can escape its clutches, even a beam of light. And now, imagine 2 of these space monsters colliding. Scary? You bet. Astronomers have spotted 2 supermassive black holes feasting on the cosmic material of 2 merging galaxies in distant space. This phenomenon is the closest to colliding black holes we have ever seen. Supermassive black holes are the largest among all black holes out there. Their mass can be hundreds of thousands or even millions to billions of times larger than that of our suns. And 2 such giants have been recently spotted with the help of an array of telescopes in northern Chile's Atacama Desert. Astronomers originally used these telescopes to watch 2 merging galaxies located approximately 500 million light-years away from Earth. Thanks to being alert at all times, scientists have also noted that 2 gigantic black holes were growing alongside of each other. Apparently, these black holes came across each other when their host galaxies collided. One of the black holes is around 200 million times the mass of our Sun, and the other is a bit smaller, only 125 million times larger. Now, we can't see black holes directly. If you were to travel to a black hole, you wouldn't notice it until it was too late. The only detail that would give away the approaching black hole would be a slight blurring of distant stars due to the hole's gravitational lensing effect. The two black holes we're talking about are no different. They aren't visible directly, but are surrounded by bright clusters of warm glowing gas and stars. All of this has been tugged close by the black hole's gravitational pull. Time will pass, and these black holes will start circling each other. And eventually, they will collide, creating one, probably even bigger, black hole. Scientists have been observing these black holes across multiple wavelengths of light and have come to the conclusion that they are unique. They're located the closest to each other astronomers have ever seen. The distance between them is a mere 750 light-years, which, astronomically speaking, is just next door. Even more exciting, this distance is close to the limit of what modern technologies can detect. The thing is, such ginormous merges are more typical for distant galaxies. This makes it harder for Earth-based telescopes to see them. But the sensitivity of ALMA helped astronomers observe those bright and compact regions where matter swirls around the black holes. Imagine how surprised astronomers were when, instead of one black hole, they discovered two of them, munching on the dust and gas stirred up by the massive space merger. Galaxy mergers are way more common in the distant universe than in our neighborhood, and this discovery may mean that such black hole binaries are likely to be much more common than we previously thought, too. And if pairs of black holes are so common, it might make it easier for us to study gravitational waves. These waves, also known as ripples in space-time, occur when black holes collide. If we talk about the recently discovered pair of black holes, it might still take them several 100 million years to crash into each other. But by observing their behavior, scientists can figure out how many binary black holes there are that are about to collide in the universe. Also, this may give us more insight into what is going to happen when our home Milky Way galaxy collides with the Andromeda galaxy in around 4.5 billion years. By the way, the first photo of a black hole was taken in 2019. An international team of scientists, consisting of more than 200 astronomers, had been working for years to get this result. And their efforts finally paid off. The object in the photo is about 55 light-years away from Earth at the center of the galaxy M87. You can now admire this amazing space phenomenon thanks to the work of a vast global network of telescopes called the Event Horizon Telescope Collaboration, or simply EHT. The event horizon is a point of no return on the outskirts of a black hole. When something, for example, matter, radiation, or light, reaches this boundary, there is no way for it to escape. To capture the very first image of a black hole, scientists created a virtual telescope that turned out as big as our planet by combining the power of 8 radio telescopes. But it wasn't an easy feat. The researchers had to simultaneously point the telescopes in a meticulously planned order with the help of precise atomic clocks set on each telescope. Plus, they were constantly monitoring the amount of moisture in the air, since too much humidity would ruin the images. To keep the chances of rain to a minimum, they even constructed the telescopes in super dry regions, such as the Atacama Desert in Chile and the South Pole. All in all, the process resembled a carefully coordinated dance. But thanks to these preparations, in over 2 weeks, the telescopes collected 5,000 trillion bytes of data. It was then processed by several supercomputers, and scientists finally got the long-awaited images. And what they observed was a monster of a black hole measuring about 25 billion miles across. Now, how about we talk about the coolest black hole facts? There are baby black holes called primordial, and they're really tiny. They vary from the size of an atom to that of a mountain. There is a theory that galaxies get formed around black holes. This means that when a large star explodes, a black hole appears in its place, and then the rest of the galaxy just forms around it. There is a supermassive black hole right in the middle of the Milky Way galaxy. Its name is Sagittarius A star, and it's 4 million times as heavy as the Sun. And nope, we're not going to be pulled into this hole. It's more than 26,000 light-years away from Earth, and that's too far for this monster to have any influence on our planet. Besides Sagittarius A star, there are 100 million medium-sized black holes in our galaxy. And can you imagine how many black holes in total there are in all 100 billion galaxies that exist out there? Nah, you do the math. If you ever find yourself near a black hole, be ready that time will slow down significantly. It may work for you if you aren't so eager to grow older. Just don't let yourself be tugged into the event horizon. Whoops, bye-bye. Black holes aren't some hungry predators that roam the universe preying on poor, unsuspecting planets. They just gulp down the stuff that ends up too close to them. On top of that, they sometimes fling out spitballs the size of a planet. How does this matter escape the pull of black holes? Well, typically, it manages to slip away before going past the point of no return. In fact, with Sagittarius A star, we should be worried not about its gravitational pull, but about the very spitballs. After all, the monster black hole hurls them in the direction of Earth at a speed of 20 million miles per hour. What if, one day, one of them reaches our planet? If you managed to squeeze Earth to the size of a cherry tomato, it would turn into a black hole. In fact, you could also become one if you agreed to be scaled down to an atom. South African astronomers have recently come across another head-scratching black hole mystery. In a region of distant space, they noticed that several black holes located in different galaxies aligned in the same direction. It looks as if their gas emissions have been synchronized by design. Nowadays, scientists can't explain why and how black holes, which are about 300 million light-years away from one another, can be acting in unison. It's a puzzlement.
We all know about black holes, but what about their mysterious twin siblings, white holes? Have you ever even heard about these guys? Do they even exist? And the most important question of them all, are these two actually a big interdimensional portal? Let's find out. A black hole is a creepy space object with an incredibly strong attractive force. Its gravitation is so great that even light cannot escape from it. That's why it seems black to us. They appear when stars at least 3 times bigger than our Sun completely burn out. Turning old, such a star begins to shed layers of gas and decrease in size. Its core shrinks and shrinks until it turns into a small ball with huge pressure inside. And when it can't withstand this pressure anymore, it goes boom, collapsing on itself and becoming a black hole. And yeah, we still have a lot to learn about these guys, but at least we have some rough idea about them. But what about white holes? Why do we hear about them so rarely? And why don't we know anything about them? White holes are theoretical space objects that are basically the opposites of black holes. If black holes eat everything they see, then white holes, on the contrary, don't let anything enter them. By the way, white holes is just a name. To us, they wouldn't actually look white. Imagine traveling in a spaceship. Suddenly, you see something that looks like a typical black hole. It's surrounded by a bright, rotating, massive ring of space dust and gas. But if you continue to watch, you'll see something unusual. This hole will spit out some matter from its center. Something like this is impossible with black holes. Only at this moment will you realize that this is a white hole, because visually, they have no difference. Both of these space phenomena have the so-called event horizon, which is something like a boundary. For a black hole, this boundary becomes the point of no return. If you cross it, there's no way back for you. But for a white hole, it's more like an invisible wall you can't get through. It's like an exclusive club for no one. Here's something interesting to think about. Once, a white hole got a huge amount of material from somewhere, somehow. But then, it stopped absorbing this material and started spitting it out. So that means that it spits out remnants of the past. But what exactly is this past? Can a white hole spit out something that once existed and has long disappeared? Can these things somehow affect our world? This thought may be a little worrying, but you can relax. The thing is, we haven't discovered even a single white hole yet. It may be because we have very little actual knowledge about space. In the 20th century, Albert Einstein and his general theory of relativity hit physics like a tsunami. He discovered something incredible, that gravity, as an invisible almighty force, is able to bend space and time. This discovery was a real breakthrough. That's when scientists first suggested the existence of black holes. But it took them more than 40 years to understand these space objects, or even prove their existence. Only recently did we receive the first photo of a black hole located in the center of the galaxy M87. You might remember that one. Many people laughed at the fact that it was too blurry, but we really should give scientists more credit. This photo was obtained through international collaboration of space stations and 8 ground-based telescopes. So basically, we needed a huge amount of effort and resources to get even small proof of the existence of black holes. No wonder we still haven't discovered their twins. But on the other hand, many scientists now think that white holes may not even exist. For a long time, they were a logical conclusion of the theory of relativity. If black holes exist, why shouldn't white holes appear in the universe? But recently, scientists have begun to question if white holes are even possible. We know how black holes are born, but for a white hole to appear, this whole process needs to be reversed, which doesn't make a lot of sense. We can take an egg and turn it into an omelet, but how do we turn an omelet back into a whole egg? That's not only about food. At first, everything in the universe has some clear, definite shape, and then, over time, it becomes more and more chaotic. This is one of the universe's statistical laws. Moreover, it seems like white holes wouldn't be able to exist for a long time. They would throw a lot of their mass and material into space. All this would gather and gather around them, until, eventually, a white hole would collapse and form another black hole. What a weird cycle. But this is what this process looks like if you use common sense. But we all know that the universe is way too cool for our small, simple brains. There are so many things in it that don't make any sense, but they still exist. Some physicists are trying to bring white holes back from scientific oblivion. Their main argument begins with the question, what happens with things that enter a black hole? They can't just disappear into nowhere. According to physics, no matter in the universe can simply turn into nothing. It never disappears. It just changes. So what happens inside a black hole? What happens to a black hole itself when its lifespan expires? And how is a white hole born? As you've probably guessed, these questions may all have one answer. The two holes must be interconnected, and they may even be some sort of portal. For this to be true, we need to violate the equations of general relativity. And we know that Einstein's theory has been considered inviolable for years. But here's a fun fact. We did finally challenge it in 2022. 3 scientists got the Nobel Prize for proving that Einstein wasn't right about many things, and the universe is way more complicated than we thought. In other words, white holes can really exist. They may be kind of crazy and incomprehensible to us, but their existence is still possible. If they did, how would they work? Well, we have a few ideas. For example, some suggest that a white hole could be a child of a black hole. Over time, a black hole could grow old and become very small. Then, the processes taking place in it would cease to obey common sense. Pure quantum randomness would come into play. Yada yada, particles create some madness and chaos, and boom! A black hole turns into a white hole. Such a white hole would be the size of a tiny particle and weigh about as much as a strand of human hair. It wouldn't have the incredible gravitational mass of its ancestor, but it would have its insides. In other words, this white hole would store everything that the black hole swallowed in its previous life. And sooner or later, it would start spitting this information out. If this theory is true, then one day, white holes may begin to dominate our entire universe. This could happen when all the stars burn out and all the black holes dry up. But that's in the most distant future you can imagine. We're talking about trillions of years in the future here. The universe may not even survive for so long. There's also another option. Maybe our entire universe is the creation of a white hole. Some physicists say that the Big Bang looks suspiciously like the potential behavior of a white hole. Both of them are very similar mathematically, and who knows, maybe they're right. In any case, there are tons of things in our universe we have no idea about, and maybe one day we'll discover the secret of these twins. Let's just hope that they'll turn out to be some cool interdimensional portals. Our Sun. Scenario 1. Something strange just happened now. Every TV channel, the news, they're all talking about a black hole that came closer to us, on the spot where our sun used to be. You can even see an accretion disk, and the background of the sky looks kind of distorted, which means it got really close. Normally, black holes are so far away that we can't see them with the unaided eye. You can't even see them with a telescope directly. What's it doing here so close? And where's the sun? Did the black hole swallow it? The sun used to be in the center of our solar system, far enough not to burn us, but still close enough to give us light, warmth, and beautiful scenes when it rises in the east and goes to rest in the west. Hey, this one even rhymes. Well, it gave us life. The most massive body in our solar system contains 99.8% of its total mass. It's so wide, you could fit more than 1 million Earths inside of the sun. Maybe our sun turned into a black hole, but it's way too early for that to happen. I mean, that's how they form, when enormous stars come to the end of their life cycle and explode, which is called a supernova. They end up collapsing on themselves, becoming very small. It's a tiny size and a huge mass. That's what makes black holes' gravity so strong, and even light that comes too close can't escape. And all the stars in the universe are shrinking and will disappear at some moment. Our sun loses 4 million tons of mass every second, and eventually, the only energy left in the universe will be generated by black holes. A black hole is surrounded by dust, gas, and radiation. The radiation is very dangerous, so we hope our planet won't come near it. Our solar system doesn't have light anymore. No light and no heat either. So even Mercury and Venus will probably get covered in ice pretty soon, not to mention Earth. Do I need to say nothing will survive this new ice age? The only salvation might come from the accretion disk that spins so fast it generates heat, but that's too many chances to take. Still, at least if the black hole has the same exact mass as the sun before it, all the planets will remain in the same orbits, Earth included. But if it has a mass bigger than our sun, which is something our scientists are currently trying to figure out, then bye-bye, solar system. It was nice knowing you. Scenario 2. Oh no, what's happening? It was supposed to be a nice sunny day, but now you see darkness descending so abruptly. How come it's night, yet the clock says it's 2 p.m., and the moon looks different? The TV reports say our sun is gone. And due to some mysterious events, the moon is not orbiting the Earth anymore. It's in the center of our solar system now. We don't have much time left. Since the sun is not in the center of our solar system, we now have 8 minutes and 20 seconds to become aware of it. It may take millions of years for the sun's energy to travel from its core to the surface, but 8 minutes and 20 seconds is exactly how long it takes for sunlight to reach Earth. The light takes a journey across 93 million miles, which is the distance that separates us from the sun. We're not in the habitable zone anymore. The habitable zone is the distance from a star, in our case, the sun, at which liquid water could exist on the surface of a planet. Now that the sun's gone, its light won't reach us anymore, and our planet will gradually become a frozen, lifeless rock. Who knows if we'll have enough time to come up with some technologies that would provide us with the solar energy we need to sustain life on Earth. If not, well, millions or billions of years later, scientists from some other civilizations would explore it, trying to find evidence if life ever even existed there. It would be the same as we do with Mars and other planets in our solar system. trying to figure out if they've always been lifeless or if there might be a sign that some organisms used to live there. Something else, also vital for our life, travels at the speed of light: gravity. Without the sun, for roughly 8 more minutes, the planets would continue circling the empty center of our solar system until the clock ticks and they finally drift somewhere into an unknown direction of outer space. Our moon doesn't have a strong enough gravity to keep us in place. It can't shine so brightly to give us warmth and support life. It's so far, we can barely see it now. Without the moon that peacefully travels close to our planet as it used to, we can see tides are getting lower incredibly fast. Oh, and it's becoming really windy. Winds are so much stronger and faster now. When things were normal, our planet sat at a 23.5-degree tilt, which is the reason we had changing weather and seasons. Now the tilt is so extreme, it's getting very cold, very fast. And our time is almost up. People are screaming, everyone's in panic. We still have maybe 1 minute left until we sink into eternal darkness. Scenario number 3. We're not sure what exactly happened and how the life we carelessly lived yesterday came to an end. No one could predict it, but it seems that, out of nowhere, a giant neutron star took the spot where our sun used to be. It's not something we'd recognize on our own. We just noticed something was different, and the sun kinda got smaller and weirder. The rest we heard on the news, and no one knows how it happened. Maybe our sun is somewhere behind the neutron star. Or the star pushed it out of our solar system and into an unknown direction? A neutron star is the densest space object we know about. It has almost twice as much mass as our sun, but it's all squeezed into a star only 10 miles, 15 kilometers, across, which is about the size of a city on Earth. A neutron star forms when a huge star runs out of fuel. It collapses in a big explosion. Its very central region, the core, collapses, which is why every electron, negatively charged particle, and proton, positively charged particle, crush together into a neutron, which is either uncharged or neutrally charged. We're in a very tricky situation now, basically waiting for our end to come. This neutron star has gravity 2 billion times stronger than the one Earth has. This means our new sun will pull all the planets in our solar system towards itself and eventually destroy them. It's already started. For the first time that we know of, the planets are leaving their stable orbits, attracted by the powerful force of the neutron star. It's becoming chaotic pretty fast. And it won't stop there. A neutron star rotates more than 700 times every second, which is incredibly fast. Our sun rotates once every 27 days. So, after it destroys all the planets, including us, this star will continue whirling throughout the universe at about 1/5 the speed of light. Maybe it will slow down and fizzle out with time, but maybe not. After thousands of years, many neutron stars begin to slow down and blow out. But that doesn't always happen. If it meets another star, it will orbit it and start to feed off its atmosphere until it collapses at some point and turns into a giant black hole. Our sun was going to burn out anyway. Until the neutron star showed up, the sun was 4.6 billion years old, which was about halfway through its lifespan. It had already burned off about half of its hydrogen stores and had enough supplies for another 5 billion years. It was eventually supposed to end up the size of the Earth. After running out of fuel, it would have simply collapsed. It would have retained its enormous mass, but its volume was going to be similar to that of our planet. No sun, no life, so the result would have been basically the same. But this way, it would have been a slow process. Who knows if humans would even inhabit this solar system in those times? But with neutron stars, things move towards the end pretty quickly, and it's way more chaotic. If the neutron star was going crazy somewhere far away in another galaxy, we'd only see it in the shape of a distant flashing light that we call a pulsar. But this way, boom!
Okay, here's the deal. Something is bound to happen that can affect everything we've ever known about space and time. You've heard about black holes, right? That denser-than-life type of phenomenon that usually exists in the center of galaxies. 2 of them, located 9 billion light-years away from Earth, are expected to collapse into each other. And my oh my, I do not want to be around to see that. Let's get one thing straight. Black holes are the most powerful things in the entire universe that we know of. If they decided to go all Revenge of the Sith on us, we'd be doomed. A black hole was once a massive star that went supernova, meaning that the star collapsed onto itself, and the sheer magnitude of the explosion created a black hole in its place. Oh, by the way, black holes do not pull things inside like a vacuum cleaner. That's just a popular myth. Say we were to replace our sun with a black hole at the center of the solar system. Not much would change, except that maybe we'd all freeze. Yep. But black holes can do something much worse than vacuum stuff. They can delete the universe itself. If a black hole was to follow a normal timeline, it would go from its creation to total disappearance. But this process is very, very slow. I'm talking about billions and billions of years before a black hole loses its mass entirely. That happens because they're constantly losing their mass every single second. Black holes radiate their mass away, like a boiling teapot loses its water as steam. Yet, things rarely go as planned, both in our lives and apparently in the universe itself. So it wouldn't be that much of a surprise to find out that two black holes are en route to collapse. That's what scientists have found out recently. And let's just say that this is one of the reasons why the scientific community is freaking out just a little bit. The first question that comes to mind is, what does that mean for us humans? Total annihilation? No need to be this dramatic. The best case scenario, we'd be in for an interstellar type of experience. Roll me in, please. Let's rewind a little bit to understand how this would happen. 45 years ago, a group of scientists began noticing a weird behavior coming from a galaxy far, far away. The galaxy is found 9 billion light-years away, and its scientific name is a mouthful, but let's just call it Super Far Away Galaxy. You might be asking yourself, well, how did scientists observe this black hole so far away if it doesn't emit any light? Good question. That's because black holes gather disks of gas around them, and they emit some of this material into space. These jets can be detected from a distance of millions of light-years. Now, if these hot gas jets are directed towards space, then scientists give these black holes a special name, blazars. A particular blazar has been gaining worldwide attention recently. Long name, but let's just call it Andy. Imagine you're a scientist at Caltech and you're looking at a blazar in your radio telescope and you notice its strange behavior. Its brightness goes on and off, like the ticking of a clock. At first, you don't understand what's happening over there in a distant corner of the galaxy. But then, you realize there must be another black hole circling the first one. In other words, scientists discovered that Andy was being orbited by another blazar, Gomer. And the regularity of their twinkling can only mean they are close to a total collapse. It gets worse. Each of the two blazars is estimated to be a few 100 million times the mass of our Sun. Have you seen our Sun? It's huge. It's already 333,000 times the mass of our Earth. This means we're destined to face something out of our league. Now, this is not the first time scientists have detected something like this. In September 2015, the LIGO Observatory detected a collision of two black holes. Each of them was as heavy as 30 suns, and an equivalent of 3 solar masses was released once they crashed into each other. And guess what? This gravitational wave passed through Earth at the speed of light, but we really weren't affected by it. Maybe you were sleeping and felt something weird in the air, but nothing significant happened to us as a species or to our planet. But that's because the blast was weak. The thing is, the expected collision between Andy and Gomer will send unprecedented gravitational waves throughout galaxies, and they will reach the solar system. But what is this shock wave actually capable of doing? Well, it could stop our Sun from releasing gas for a few minutes, which means it would stop heating the solar system. So, let's say you were going about your summer day, and out of the blue, the atmosphere froze for a few seconds. Doesn't sound too nice, huh? But that's actually a better possibility than the next one. In one of the worst-case scenarios, a blast from the collision between Andy and Gomer could break bonds between atoms and make everything disintegrate. You, me, your cat, we'd all turn into flying particles floating in the vacuum of space. This may sound scary, but scientists say that an atom is made out of 99% empty space. This means that everyone on this Earth, all 8 billion of us, and everything that exists, planets, objects, animals, are all made up of 99% empty space. So perhaps all that Andy and Gomer would do is separate all of our atoms and desolidify us. Then again, the blast could mess with the fabric of space and time as we know it. You remember Albert Einstein, right? Crazy hair? He's the name behind the theory of relativity. Einstein discovered that time is relative. It's always dependent on the observer. This would mean that time is not the same throughout the cosmos. Why though? Well, because Einstein's theory of relativity is also a theory of gravity. Einstein discovered that gravity is the effect that objects have on the fabric of space-time. Every object that has a mass, including you, me, your cat, and our planet, creates a warp or a distortion in the fabric of space-time that causes it to bend. The bigger the mass, the bigger the gravitational force, and the bigger the distortion on the fabric. It may sound complicated, but hey, this is what creates different perceptions of space and time throughout the cosmos. This is why you'll age differently on Earth and on Jupiter. This is why time passes completely different for astronauts on long missions and for people that remain on Earth. And this is why a collision of two mega blazars could mess with our perceptions of space and time, due to the sheer force of its gravitational shockwaves. Got it? Not to mention that black holes are already a huge warp in the fabric of space-time. You remember that interstellar scene, right? Where the lead character bends the space-time continuum through a black hole? Now, don't try this at home though. As far as we know, anyone who chooses to go inside a black hole has no guarantee of making it home again. Scientists say that this blazar explosion will happen in approximately 10,000 years. But wait a minute. If this blazar lies 9 billion light-years away from Earth, it means that these two black holes should have already collided long before our solar system and home planet were born. You see, the solar system was born around just 4 billion years ago. And since it takes us 9 billion light-years to receive the light emitted from the blazars in the first place, this means that the collapse of the two blazars already took place, and it'll reach Earth 10,000 years from now. This means the shockwaves are already making their way through the galaxies at this very moment. But still, it's not something even your great-great-great-great-great-great-great-grandchildren will be around to see.